I'm gonna make sure that I can hear. I can see myself. Here we go. I'm gonna make sure that I can hear. I can see myself. Testing. Testing. Okay. Oof. All right. I'm live. Everything should be working. I think. I'm like 10 out of 10 sure. All right. So last night I did a thing. After I headed out. But apparently um generating all of the stuff for this is a bit too much. So I think what we're going to do is we're just going to plop this down here and hope for the best. Is it not coming in? What if I just delete it? We'll just delete it and re-import it. There we go. This will take a couple for it to get imported, but it will give us an environment to go around in. nothing will work properly, but whatever, it doesn't matter. I left it generating the collisions overnight and it never finished. It was like at 12 hours almost. And it was like, yeah, I'm 12 hours in and there's no end in sight. I'm just like, oh cool. That's so nice. For anybody that's wondering, I am loading in a 620 megabyte FBX file that will be replaced. Okay, it will be replaced. It's just going to take a little bit for me to actually replace everything. It's a slow and steady process of replacing things as I go. So here it is. And then we bring this in here. And there we go. Look at that. And then all we do is we come along here and we're going to delete a bunch of stuff that we don't need. Because this has like cameras that aren't not needed. Miss Raylight. Also not needed. There we go. So this is our little world here. And we're just gonna go in. There's some weird little point issues. First, great Twitch has been Twitch again. Twitch was being Twitch again. Nice. Well, you definitely are first, so congratulations. So this is my terrible map at the moment. Oh yeah, that's just like weirdness. This is my map though. I'm not sure if you've seen any of this. So this is me bringing the map out, or the base map from Unreal into Unity. Let's see, this is where we want to be. It's very white right now. Well, as a concept, it works, right? Yeah, it's definitely that. So let's grab the player. Where's the player? There's the player. I'm gonna bring the player over. Also, I seem to be fat fingering all sorts of keys today. I know that feeling so well. So here we are. Did it go under? Oh, no. Okay. Sweet. There we go. Then we want to grab our little AI people. Let's move these people over here like so. And our one pedestrian. There we go. How is the porting going? I'll show you. So the vehicle works, but it doesn't feel good to drive yet. But 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 if I go like this. Oh, she's already hitting something. Wait, what? That's not right. Okay, where's my player? There's my player. Let's move the player closer. What what the fuck happened to her? Let's just go like this. We'll go boom, and then we'll hit play. And then we're gonna hope for the best. Interesting. Just interesting. Is she not a kinematic person right now? Okay, what was it? It was root. Oh, this is why. I said is kinematic. These are all supposed to be set to true. I'm guessing that didn't get saved because um reasons. I don't understand. I'm constantly saving. I'm guessing there's a save. Is there a special save button for Unity? That's the head, neck. I figured it was just Control S, but I guess I was wrong. How's the porting going? I was joking about Carmageddon thing, but now I actually realize what your game is about, and it's actually very close to Carmageddon. Yeah, it's kind of Carmageddon-y. You were joking about it, and I was like, oh yeah, no, that's actually kind of true. It is kind of Carmageddon-y. The porting's coming along. I'm getting used to Unity. It's definitely a bit of a learning curve, but I have the ragdolls mostly worked out. Just apparently this didn't save, which bugs me, but it is what it is. So apparently this did not want to save, even though I thought I saved it. Actually, I probably should have saved it as the prefab. Oh wait, she's not a prefab. She should be a prefab. Let's do this. We'll create a folder. AI. Pedestrian. There we go. Now we can add her next to her. There we go. And then if I hit play, she shouldn't fall down immediately. There we go. And now I can run her over. Nope, because I still have the wrong stuff. God damn it. My apparently my scene didn't save correctly, which is the problem that I was running into. There's her collider. I don't like how white everything is. I want to just always be able to like easily save. Is there like a save all? Because apparently if I make a change here, right? If I do that and then I'm like over here and I hit save. No, it does work. What the fuck? I don't know why why it wasn't working yesterday then. So weird. Okay, so what did I do? I definitely did something yesterday to get this to work. And now it's not working? Oh, right. This doesn't have the trigger on it anymore, right? Oh, that's why. Okay. Add a component. Box collider? No, that's not it. Or is it? No. I think I put it on. Yeah, I know the truck's got the box collider there, and it's a trigger. And then if I go into my code, we go to the vehicle controller. We have the here. I have been hit there. Okay. Okay. And if we come over to here and we go to the log, we are seeing it. But why is the ragdoll not being called? Okay, so if I go like this, it's going to put us in the game. And if I go back into scene, grab that. Yeah. Okay. Okay. And then I do this. Oops. Where's my controller? There's my controller. There we go. Root bone has not been assigned. You probably need to. Oh, that's why. Okay. There's the root bone not being assigned, and the root bone needs to be the pelvis, which is that one. There we go. And then if we hit play now, this will work. Whee! So if you change prefabs itself, it's also saves that. The prefab itself should be changed, right? That should be. It's not changed. Okay, so I need to do this on the prefab itself. Here we go. Then we can save. Beautiful. There we go. Now if we hit her, we can see that ragdolls are working. It's beautiful. Ragdolls work. None of this has collisions though. So like if I drive around, like this entire thing has no collisions. Wee. There we go. The end of the world is nigh. This is effectively my map at the moment, for the time being at least. Now I have a cube. Is this the cube? No, that's not it. Is it this cube? No. Is it this environment one? Ground. There it is. All we do is we're just gonna go like this and expand it outwards. And this way when we run over things, we can see things better. So then if we go jump down to player, what I want to do is I want to go to my materials, and then this is the checkered material. No, no, don't do it. That's horrible. It's horrible. Don't, no. God damn it. There we go. Okay, save. Okay, so I can't change the material for this ground without changing the material for all of it right now. Damn. Damn. Maybe? Can I do this? No. Edit? I don't know what's going on here, and I feel like I should be concerned. It's too white. But I also don't think that I can change it. I can't change it. Damn it. Oh well. Also, if you make changes to the prefab. Okay. That's where we were. Okay, so now I can kind of drive around this city, and we can see we can use this as a test to see like how good or bad the driving actually ends up being. Right now it's terrible, but that's okay because it's going to get better. Man, I just drifted right through that fucking thing right there. Look at that. We This thing's like impossible to steer. Whee! Oh, so good. Okay. All right, let's fix that. It's a bit much right now. Save. Let's so there's a couple things that I want to get done today. I want to do um I want to work
saved our data.
I want to work on driving and getting the driving really nailed in. And then I also want to work on uh getting the dot system started.
Data, and we can go back to our left wheel. Okay, so we now call this function from our update, and it should work as intended. All right, let's check it out. All right, so now when we move the car, you can see the suspension working, and if we kind of make the car fall a little bit, you can see that the wheels roll back as well, which is what we want from a car. So now what we want to do is actually have the engine move the car forward, so actually rotate the rear wheels of the car and steer the car left and right. So
I think that I have that. Let me double check that though. I thought that my wheels were turned. Okay, so then if we go to scene. Yeah, they turn. They turn. Okay. So, oh yeah, yeah. Here. One sec. Um, this is where I'm at in Unity so far. It just fucks right up. Yep. It's so long and thanks for all the fish. It's a bit too it's a bit too much power is what it comes down to. I think maybe we do 500. That will probably fix the issue of how far she gets flung. Hey Cutie, is there a way to get better compile times? There we go. That's better. About 500 seems to be the max that we want to input. There we go. Okay. So now when we're not accelerating or braking in a fixed update, for each wheel control, if wheel controller dot is or motorized, brake torque equals brake torque times 0.25. Well, okay, so every time I make a change and I hit build, right? I get to wait like a year for Unity to finish recompiling so I can hit play. And it kind of it's kind of annoying. Oh, right. Excel is accelerating, so we do this. We come down to here and we do fuck. We added God damn it. For each wheel controllers. Wheel controller. In wheel controller. If wheel controller dot motorized wheel controller dot wheel collider dot do, and we want to do wheel controller dot wheel collider dot brake torque equals 0 if wheel controller dot wheel collider dot or is braking or if not is braking. Yeah, then I get those. They're a constant state of annoyance. What do you mean by that? Rush Joe, what the fuck are you? The fuck you here too? Of course. Rush is one of last year he was one of my top viewers for hours watched. Oh, that feels better. There we go. Yeah, Rush and I are good people. Rush is good people. Of course. Of course Rush would be here. I forgot you like to get around so good. I've known Rush for a while now. But yeah, no, for all seriousness, like last year I checked like when they do that like your year in Twitch or whatever like that. When I looked at it, Rush was like number he was in the top 10. I wasn't really he's usually lurking. I had a great conversation with his wife today though. It already feels better to drive when it's like this. Holy shit. It's surprising that this actually gave it a lot more movement. Whee! Whee! The counter steering. Okay, so now I want to take a quick look at the car to see whether or not it's turning. Okay, yeah. So it turns, but look at how it turns. No wonder it's hard to control. There we go. Okay, so he was suggesting using long cube gun. Let that be part of the magic. No, it's got to feel good to drive.
To do this, we need to get the component. So we need to create a function that checks the input. We will also create a public float point, which will show the gas input. It's basically the forward motion or the backward motion, like pressing the pedal, and the brake input as well. And so we will use the gas input. If it's positive, it will move the car forward, or if it's negative, it will brake the car. So input. And we will also get the steering input. So I have it as a public float so that I can see what's going on. All right. So now we go to our check input void, and we get the input from the input manager. So we set the gas input to be equal to the input dot get axis.
Give me a second. I also want to just pull up his stuff. I think I've already got it pulled up, but yeah, I did. Okay. To car controller. How did he deal with the braking, like the engine braking? Because I don't actually check input, apply motor, apply steering, apply brake. Where's his apply brake? This is technically better. Oh, I see why he did that. So the rear wheels and the front wheels can have different braking power. I might actually change that. That's actually not a bad idea. We already know which one. These I'm gonna just leave the way they are. What the fuck? You even watching a tutorial? Of course. Either go left or right, no straight. Yeah. Apply steering. There's the wheel position. That's not really what I care about. Don't worry, you'll get there. Okay, so mesh render, particle systems. Okay, so what we're gonna do is I'm gonna come back to that, but I want to add in his curves, animation curves. Here we go, steering curve. And I want to do this for the braking as well. So let's add that in. Steering curve. Then let's see here, gas input, braking, steering input, smoke, motor power, brake power, slip angle. Do I have a slip angle? I want to have a slip angle. Steering range. We can see what are. I'm just gonna bring over his real quick here, so I have them locally. Okay, so we don't care about these because we already have them. We don't care about these because we already have them. These are just these. Effectively, yeah, effectively. There's our speed is something else. But our speed, I think I wanted to have as a curve too. Torque, maybe? Torque curve? I don't think that's right, but whatever. Slip angle is a float. Braking power to do. We'll come back to it. It's fine. What's the issue here? Oh, I've got it up here. Okay, yeah. We can delete that. See, we've got max speed. It's 20, so we can get rid of that. To do brake torque. That's motor torque in there, and then we have slip angle. There we go. Means sarcastic. Half kidding. Kidding, but about something sus. You don't need to worry about the others. Think I'm getting too old to understand all the emotes. If you're not 40 and above, no excuse. Dude, I barely know any of these things. These we can come back to. The rigid body, I think is already getting set. It's up here. Input action, that's fine. Yeah, I think we're mostly good on this. There. Okay. Let's see. Then we can go back to his, and I want us to take a look at his. Here's his update. So we got check inputs. We've got the gas pedal dot damp. Oh, it's the press. Okay. And then if we go to the apply motor, wait, what's his apply motor here? If gas pedal is, no, let's check inputs, updates. Apply motor. Oh, I see what we're doing here. Yeah, I see what's going on. Okay. Okay, so I get what he's doing, and I actually like that system. It's better than doing this. Yeah. It's potentially better. It's going to be less error prone in the long run. So instead of doing this, we can get rid of this. Well, yeah. No, we just got to do it. And there's only one of these, so it doesn't matter. There. And then we can get rid of this for now. I'll just get rid of it. It's fine. There's our steering. We'll come back to that later. Then in here, we get our float, which is essentially this gas input. I'll just name it the same here. Public float gas input. gas pedal. Gas. Is that right? Or is it 1? Oops. Gas pedal. There. And then he's got brake pedal. Public float. Brake pedal. Left, right button. That's fine. We'll come back to that. And then applying motor. There. But what we're doing here is gas input. If it's pressed, we do a plus equals gas pedal down. So if we do accelerate, we grab the float, which is a 1 or effectively between 1 and 0. And then we do this, and then is motorized. We do the do times it's his power, it's motor power times that. Yeah. So motor torque times this. Yeah. Okay. So my motor torque is a bit high, probably. So maybe only 1500. There. But those are public, so I think these should be able to be changed inside the editor. But let me see if they can be changed. Okay, yeah, 1500. Or is it going to reset it when I go in? No, it's not. Okay, beautiful. There we go. And then we're going to get rid of our max speed because we don't actually care and it's not being used. Steering range at max speed. That's fine. We want our steering to be the curve or nothing. We can get rid of these because we don't care anymore. Yeah, okay. There we go. Our steering, we need let me just make sure that I build this. And then we can wait an hour for this. Wait, vehicle is braking, but wait, the field vehicle is braking is assigned but is never used. Oh yeah, we're not using either of these anymore. There we go. Oh, wait. Still using something. Oh, no. Okay, yeah. It's still technically being used. Okay, that's fine. It's fine. We're going to clean this up and make this better. Okay, so then we need a curve, right? And this is our steering curve. So we'll say, how do we do this? Is it just like this? And then how do we add to it? Add a key. There we go. Beautiful. Okay. And then we're going to come down like this. Ask and you shall receive. Exactly. Add a key. Just going to go like this. This is the general idea of what I'm thinking we should probably have, something like this. There. And okay, and then if we come back to here, we can say we can see his apply wheel position. No, it is apply steering. Okay, so the steering input is up here. Where's my fixed update? Here we go. This is the steering input. Okay, and then let's take a look at what he did. Steering curve dot eval. There's our steering input there, right? There. I think this is supposed to be a float. Do I have that as not a float? What do I have this as? Where is it? It's not that. Wait, is it this? Where did I stash it? Input system. There it is. Oh, this is a vector 2D. I think this just needs to be a 1D axis. Damn it. Right? This is just a flow, right? Steering input. Yeah, his steering input is just a float. Yeah, that's what I thought. Okay. The steering input can be just a float, which is this. Neither. There's my left. So we'll go this way. Then if we duplicate, we do right, and this is not going to be negated, positive. Then that's this one needs to be negated then. Then duplicate and we do this. Right? And then this is going to be positive. And then we're going to duplicate this. And we're going to do right arrow key. And duplicate this. And do this. Left arrow key. Beautiful. And then negative, negative, positive, positive, positive. And then we just need to save. Save. And we can do this. And then we have our there. And then our speed. Where's speed being set? Ah, that makes sense. Okay. We can stash a version of speed. Fixed update, fixed update. Here we go. Speed equals rigid by velocity magnitude. Yeah. Asking you shall receive. Find silly whenever something like that happens to me. How do I do this? Press right click. Oh. Yeah, that sounds about right. Oh. Wait, what? No, that's not what that said. It said, oh, wait. Rigid. Please use rigid body linear velocity. There we go. Okay, now we have this, and we can go to the here, speed. Slip angle. We can we'll keep that for now. Don't we already have this? Oh wait. This is rigid body dot linear velocity. And then this would be steering for each. Wheel collider wheel in steerable wheels. Yeah, it's just that. Beautiful. And then if we come up here and we do start to do fixed update here, we can do apply steering. And then we build. And do that. And then we're going to clear this. Controller 69. No, what was it? It was player RB. Didn't I just change this? Mm, what the fuck? I just did this. Rigid body dot linear velocity. Then this here becomes for each. I feel like I just did this. Wheel collider in steerable wheels. Wheel collider Okay, now we do this. And beautiful. And then we can do this. Okay, and then we come back to, let's take a quick look from the side here. Cannot read value of vector 2. What? Oh, it completely just did away with all of my stuff. 10 out of 10, 10 out of 10, 100%. The most amazing thing ever. Float. Float. Wait. I think I put this down here in the steering, right? Yeah, apply steering. There it is. Okay. So all we need to do is come up to the fixed update and add in the applied steering here. And voila. We did it. There we go. Then if we go in there, do this. We can see that we've definitely got some fuck ups here. It's great, 10 out of 10. Apply steering. What we want to do is debug.log steering input. Yep. Let's make sure that it gets the right values. There we go. Yeah, that's correct. Why is it not steering then? Actually, is it steering? And it's just not affecting the wheels? Oh, is it maybe not steering enough? Hmm.
I think it's horizontal, not vertical.
Okay, I want to get this right. Okay. So we do have this. Hmm. Yeah, that should work. If I go like this, right? Give me a second here. There. Float. do steering. So give me 1 sec here. So if I do this, we just do this, right? Let's see if this does the thing that we want. So if this doesn't do the thing that we want, then it means that there's something else going on. That's the problem. Because this is a vector 2 was working. Okay, yeah, no, it's working. Okay, so I think I had a problem with my steering curve.
If I'm not mistaken, let me check. So yeah, it's vertical for the gas input, which is basically the up arrows and the was the W and A, W and S, and the steering input will be system. So to create a steering system, some people just use a normal steering. So when you press left, it goes 60 radians to the right, and all the time, no matter the speed. But that's actually really wrong because when you're going 100 miles per hour, you don't just go right and expect the car to either steer or not die. So to fix that, we will use a curve so that we have a function over the speed and the angle of the car. So to do that, we need to have the speed of the car. Before we do that, I have forgotten to add layer is equal to the velocity because in function you need to use animation curves. So we will create another function. I will call it create. That's wrong. Curve as a parameter. So you need to evaluate round up. And this here. That's wrong. Like let's create it from the ground up. All right. All right. So we need to go to the 60 degrees angle. So it's around here.
Oh,
65 is a good degree.
okay.
And go to around 50 miles per hour, I guess. All right. So that seems like a logical steering curve. Let's do it 60 miles an hour. Yeah, like that looks.
I see how this works. I see how this works. And I see where I went wrong. I see where I went wrong. This is supposed to be, can I just do that? Yeah, okay, there we go. Is there a way to just edit these values? Can I hard code this? Edit key? Ah, yes, I can. Value 60 time 0. Oh, wait, no, I didn't want 60. I think I wanted hit key maybe 45. And then,
Okay. So now we have our curve. So let's actually not make it 0. Let's make it around 20, 15. Yeah, 15 makes sense. Create it from the ground up. All right. All right. So we need to go to the 60 degrees angle. So it's around here. 65 is a good degrees. And go to around 50 miles per hour, I guess. All right. So that's
okay, so the bottom is your miles per hour. Or your speed. Okay. This makes more sense. So here we want to come out and say wait, what? These values looked very different.
Let's do it 60 miles an hour. Yeah, like that looks okay. So now we have our curve. Let's do it 60.
Interesting. Okay. So if I blow this one up and we do an edit here, right? Edit key. And we say value of say 25 and time of 60. That's so different than his curve. Yeah, like his curve's like very different. Why does his curve look so different? Is it because it's like squished together more, maybe? But I don't think that it would be that. Did I do something wrong with my curve? Oops. Oh god, no, 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 no. That's not what I wanted. Okay, so we do this. We delete that, and then we edit this key here. And we want a time value of 0, and we want a maybe we'll say 50. 60 is a bit much, I think. And an edit key, we want a time value of, we'll say 60 and a value of 12. And then if we zoom out, we'll be able to see it somewhere. And it's very different than his curve. And I don't know why his curve looks so different. But whatever, whatever. Now if we hit play, this should work. Oh wait, do we have the steering being implied still in the wrong spot. Okay, so then we can do this, and we can, and then here we would do apply steering and build. And then play. We get no steering at all. Just none. Okay, so debug.log steering. Oops. Can I do steering input? Oh, that's terrible. Debug.log steering angle oops, plus speed, and then we want steering input. Input. We do that. We do that. There we go. And that's okay. If that's going to be what it is, it's going to be what it is. What do you mean my speed? That's a weird speed. Huh. My angle's weird.
Miles an hour. Yeah, like that looks okay. So now that we have our curve, so let's actually not make it 0, let's make it around 20, 15, yeah, 15 makes sense. Okay, so now that we have our steering curve, this should work, and it should actually rotate. Have our curve. Alright, so we need to go to the 60 degrees angle, so that's around here. 65 is a good degrees. And go to around 50 miles per hour, I guess. Alright, so that seems like a logical steering curve. Let's do it 60 miles an hour. Yeah, like that looks okay. So now that we have our curve, so let's actually not make it 0, let's make it around 20, 15, yeah, 15 makes sense. Okay, so now that we have our steering curve, this should work, and it should actually rotate our car. So as you can see here, the car wheel is moving left and right, so when we move forward, it steers.
Okay, so that's a problem. My steering curve is wrong. It is definitely that. That's definitely not the steering curve that I wanted. I don't know why it didn't save correctly. Edit 0. We're just gonna go with 60. And then edit key. We want a time of, we'll say 60, and then a value of 12. There we go. Now it's looking like his. Wait for it. That's fucking hilarious. Where even is my I don't even know what's going on here. Come on, come on, come on, come on. Where are we? What's going on here? Okay, so apparently I'm stuck going backwards now. But that's fine. That's fine. We're just gonna bring this down. Edit key 45. This steers so much better already. The oversteer and slip and everything is still a lot, but it's the speed's definitely getting there. Mm. Okay, so we got the steering working.
And when the car is going faster, it steers a bit less so that it actually works like a car. And where did I go car? Oh, so it's here. Okay, so it's steering. All right. So now it seems like it kind of is understeering here. So we can actually increase the traction of the wheels by the forward friction. We can increase the stiffness of it to 2, and the sideways friction as well to 2 for the front wheels. Let's see if that makes any difference. It should make it steer a little bit easier. Yep. Although now it is actually just turning over, tipping over.
That is good to know. Okay, so now we can come into here. I think we need to do this as the prefab, right? Oh wait, no, this hasn't been created as a prefab yet, so we're good. Hmm. Okay, so what was he playing with? He was playing with his stiffness. We're gonna have to play with this. I yeah, no, I don't think that's quite what I'm looking for, but the idea is definitely there. So let's see. Extremium slip, extreme slip, extreme value. I'm gonna have to look into what these mean. We go to here. We can do Unity Wheel Collider API. It's a wheel collider, right? Motor torque on the wheel axis expresses in Newton meters, positive or negative depending on direction. The mass of the wheel, kilograms, be larger than 0. Do my wheels have mass? 20 is not correct. I think these are much more than, they're definitely more than 20. The current wheel axle rotation speed in rotations per minute, read only. Rotation speed of the wheel measured in degrees per second. The radius of the wheel measured in local space. Is grounded indicates whether the wheel currently collides with something, read only. Properties of tire friction in the direction the wheel is pointing. Oh, it doesn't give me much more than that. Get ground hit, get world position, reset sprung mass. The transform attached to the game object. Get component, get compare tag, recast. This doesn't have all the settings that I wanted. We're missing things. We're missing actually a lot of stuff. I'm missing the suspension spring. But this is supposed to be a wheel collider, right? Yeah, it's a wheel collider, and wheel collider doesn't have any of these values for some reason. Dampening wheel of it must be larger than 0. This is what we call bad documentation. When it's missing stuff that is relatively critical for it to actually work, like to give me enough information. I was hoping to be able to ask what these meant, but I think I have to look somewhere else. Unity wheel collider. Slip. I've been experimenting with wheel colliders, and I have a bit, having a bit of a hard time understanding the settings for the friction. I'm assuming that extrumium is synonymous with static or dynamic, where an object will start to slip or break free. What's the meaning of this?
Extremum.
Extremum. The maximum or minimum value of a friction. Global maximum, global minimum, local maximum. Interesting. The slip value is the resistance to movement once the object has started moving. The desk, once moving, takes less effort to keep moving. Is a straight line that approaches a given curve but does not meet at an infinite distance. In other words, it's a line that a curve approaches as it moves towards infinity. The curve visits these but overtakes them. Don't entirely get it. No, next is the slip and value items. I've got a suspicion that they are, which I'll explain, and I'm hoping someone can confirm or correct me. Slip appears to be the amount of slipping that can occur before reaching the break point where dynamic friction takes over. So even though the object hasn't broken free, it still slips. Value appears to be the amount of force required to break free of static friction and the amount required to level out or stop dropping for dynamic friction. So an approximate slip amount before breaking free would be something like force divided by extremum value times maximum slip. In reality, the slip amount is on the curve, and this formula is plain proportional. At this point, I haven't a hunch what stiffness means. I took physics a few times and learned about coefficients and frictions, but no stiffness was ever invoked. So, to do. Oh, this is what I was looking for. Slows down when no forces are present. Wheel dampening rate. That's what I want. That's the engine brake. Wheel dampening rate. I would imagine that this would be our engine brake. Okay, so let's take a look at my static mesh here. We're going to actually tune this to be the car. So how much does a Isuzu box truck weigh? Okay. There. We're going to come back to that because that's going to be important potentially. How much does an is Oh wait. I asked the wrong question. So Elf box truck way. Do. Where's my box truck? There's my box truck version. The 6th generation Elf. Do. That's not the weight. Cab weight. It's not at all what I want. Give me the weight. Curb weight. I think it's curb weight. Oh no, here. So it's this. It's a bit lighter than what I've got. So we're gonna change it out for that. Oops, 8. There. And then what we're gonna do is we're gonna come back to Google. Wheel. Sorry. They're not that much. How much do wheel base to weight? We'll go to this one. Curb weight. Wheel base to weight calculator. No, I want the weight of a single wheel. How much does a wheel weigh? Zoo wheel weigh. 38 pounds. There we go. So here's my wheel collider. 38. Oops. No. 38. And then 38 times 2, 76. 38, 76, and 76. Wait a second. Oh, interesting. I've got to move that in. Okay. That's good to know. Good to know. Good to know. Hmm. There we go. Oh, Mr. Purple. Wait, what was that? Thank you for the follow, Mr. Purple. Oh, why is my Twitch not showing you? So weird. Twitch is being weird. There we go. Okay, so now if I go into the scene, my wheels aren't sticking out weirdly like they used to be. Beautiful. Okay, so now we can go here. What are you doing? I'm porting my game from Unreal to Unity. Yeah, it's not too bad. My cousin also makes games. Nice, nice. Does your cousin have a favorite engine? This feels super sluggish now because I've got the weights in correctly. Let's see how far she flies. Not sure. No worries. Sorry. Ugh. Have you released any games yet? Not really. Uh, there's a version of this in Unreal that you can play that's been released. Do-do-do. I probably butchered the spelling of that. But yeah, if you want to try it. There's the Unreal version is much further along. I ran into some problems with with um I ran into some problems with the if I go builds. Run into problems with I'm gonna get there eventually. Sorry. Ran into problems with the entity component system, and it's like, no. Can I tell you? I can tell you're trying to tell me something, but there's oh, sorry. Let me know when the ads are gone. Okay, sorry. So I have this version, which is this is the Unreal version. The Unreal version is substantially more farther along, right? It's got like and this version's playable right now online. So what I'm doing is I'm trying to replicate this. In Unity. And it's slowly coming along. So I can go like this and go main menu, maps, and we can see the world map, which is the map the map that I'm currently in right now in Unity is this map that I'm loading in. This map takes a while. So I'm trying to get back to this in Unity right now. But we're not quite there yet. It's a slow process, but it's gonna get there eventually. Is working on Republic and is working on Ireland. Nice. I technically have 2 games available, but neither of them are done. Kind of technically I have no, because one of them's that one's not available at all. I'm working on. I've been contracted to work on the multiplayer systems for another game as well, which is LAPD 2195, and it's like I have it, but I haven't worked on it in a while. I'm waiting for the guy who's running that project to get a bit further along before I jump too far into it. So this is the Unreal version, and I really like Unreal. But the entity component system in Unreal, which we can take a look at, because I've got it on the Shibuya map. So wow, that is blown out. I don't know what's going on there. This is really bad. I don't know what's going on there. Anyways, we can see the entity component system at work here. It's these girls, right? So this is mostly broken in Unreal, right? It's very finicky and it breaks all the time. So I've constantly got to be like adjusting it. And I don't like that. So I'm switching over. I'm trying out a port in Unity to see if the Unity dot system will solve the problem for me, and in a way that isn't complete broken dog shit. Effectively. Beams of light raid. Wait, Manadona, why are you raiding me? You're usually on longer. Anyways, it's 9 p.m. What's that supposed to mean? Anyways, so this is a play download. You can download and play that version. It's available here. And then this is where we are with Unity. The truck is turning. Haven't quite figured out all the controls yet. This is my first foray into Unity. I've not done anything with Unity yet before. Like it's not entirely true that I've never done anything with Unity, as in like I've opened up Unity and I've poked around with it. I've never actually built anything with it. You got further than me? Oh, I got a lot further than you. One sec. Let me restart this. So we have actually watch. We can hit her and she's gonna go flying. Just bam. There we go. But I'm still working out like the steering and the driving, and that's gonna take me a little bit. But if I can get it to a point where the vehicle's at least controllable, we'll be in a good spot. And I think now I can't move. Yeah. Anyways, thus is the goal at the moment. And we're just going through this stuff and trying to figure out exactly how all of this works. Suspension, that's fine. Forward friction and sideways friction. The forward friction and sideways friction properties correspond to the points in the following wheel curve diagram. So this is the amount of effort to start moving, maybe? And then this is the amount to start slipping. The value of stiffness, the multiplier of the multiplier for the two values. The default is 1. The stiffness changes the stiffness factor of the friction. Setting this to 0 completely disables all friction on the wheel. Oh. I see. I'm like 80% sure I understand. How was the rest of did you win your cuppa? Your cup of the day, Mr. Manadono? I still don't actually understand this. Okay, so this is the force is up, and then the slip is over here. But like, how do those correspond? That's kind of like what I don't understand. Okay, so let's see. youtube.com. Unity wheel.
Hey, so today I'm going to be explaining how a wheel collider works in Unity and what its function here does in the wheel collider. So let's get started. So the first thing that's on the wheel collider is basically what the mass of the wheel is, which is this thing here. I mean, that's pretty obvious. Like every object in the universe has a mass, so the wheel has a mass as well, and usually it's used to calculate what the unsprung mass is on a car. But in Unity, it doesn't really affect that much. It just adds weight on the car. So you need to keep that in mind when you set up your rigid body, that you have an extra masses that are on the wheel colliders. Next thing is the radius. It's obviously is the wheel radius here. So when you have your car, like I have here, your wheels, as you can see, there's this green little line. That's the radius we have set to Unity that our wheel is. So if we increase it, you can see the wheel increases, and we want it to basically match the mesh we have it on. So for this case, 0.3 is a pretty good value. So next thing that we need to check out is the wheel damping rate. That is how much the spring of the wheel is dampened. So when you have a wheel that's going up and down, you basically have a spring on top of it to make the transference of power to be more smooth from the wheel to the car. So that when you hit a bump, wait, I have a wheel here. So when the wheel hits a bump like this, the car doesn't go up, but just the wheel does, and the rest is dampened. So if you have a high wheel dampening, every time you hit a bump, basically the damper takes the force and makes it into heat. So your car won't feel the bump as well. But if you have a value that's way too high, it will basically mean that your spring is useless because it's not a spring anymore. It's just a rod that just basically goes slowly up and down. So you need to check that out. Next thing is our suspension distance, which is also pretty obvious. Like it's the distance between our wheel and the suspension. So you can go here and check this out. So right now it's 0.1. As we can
Chat's
see,
not
you can see the wheel becomes really high. So right now only the rear right wheel is 1, and all the other wheels are 0.1. So we can set that to 0.1 again, and yeah, it fixed it. Okay. So next thing we need to check out is the force applied point distance, which basically means where the force is applied from the wheel to the spring. So if you have a wheel like I have here, as you can see, this is the wheel. This is obviously attached to let me change the color because it's white. Okay, so the wheel is obviously attached on a spring, something like this, on a car. So the force applied point is where on the car this is applied. So you can have this higher or lower. Obviously, for the best performance in cars, you want it to have it a bit lower than the center of mass. So the center of mass is right here. You want it to be just a tiny bit lower, like a few centimeters, decimeters, but you can put it higher or lower. Unity by default just takes the position of the spring of the wheel plus the distance of the spring, and that's the point it uses. But you can change that by using the force applied point distance. So let me show you how that works. So if you go again to the car, you can see this is the wheel here. Let me take out the wheel so that this doesn't break. And if we put this to -5, which basically means that instead of here we put it higher, so we put it somewhere here. So now this spring would look like this. So this would cause the car to act like the spring is higher, and as you can see, it really doesn't like that because obviously it's really way too high. So if we put this like 0.1,
Sorry, give me
you can
one
see that
sec.
the
I
car
gotta
now acts like
rewind on this.
the springs are a lot higher than they should be. And we can do the exact opposite as well. We can put this to 1, and now, which basically means of the wheel plus the distance of the spring, and obviously to let me change. So next thing we need to check out is the force applied point distance, which basically means where the force is applied from the wheel to the spring. So if you have a wheel like I have here, as you can see, this is the wheel. This is obviously attached to let me change the color because it's white. Okay, so the wheel is obviously attached on a spring, something like this, on a car. So the force applied point is where on the car this is applied. So you can have this higher or lower. Obviously, for the best performance in cars, you want it to have it a bit lower than the center of mass. So the center of mass is right here. You want it to be just a tiny bit lower, like a few centimeters, decimeters, but you can put it higher or lower. Unity by default just takes the position of the spring of the wheel plus the distance of the spring, and that's the point it uses. But you can change that by using the force applied point distance. So let me show you how that works. So if you go again to the car, you can see this is the wheel here. Let me take out the wheel so that this doesn't break. And if we put this to -5, which basically means that instead of here we put it higher, so we put it somewhere here. So now this spring would look like this. So this would cause the car to act like the spring is higher, and as you can see, it really doesn't like that because obviously it's really way too high. So if we put this like 0.1, you can see that the car now acts like the springs are a lot higher than they should be. And we can do the exact opposite as well. We can put this to 1, and now the springs would look like the car is on rails. It's like it doesn't have any suspension at all. So you want to find the middle ground for that. That's going to be like minus or 0.002 or something like that would be the best practice to make the most realistic car you can. So next thing in the wheel collider is the suspension spring. So it's the spring that's used on the suspension. So first thing, we have 3 items. We have the spring, the damper, and the target position. So 1, 2, 3. The spring is basically the force that's applied on the wheel. So if you remember in physics, I'm sorry if I remember it correctly, but the force something like k times x, where x is the distance. Where here k is the spring. So yeah. So it's basically the force that the spring applies to the wheel. If that's too low, the spring is gonna flat out, and there will be no suspension. If it's too high, then like, once again, it will not be a spring, but will be basically a rod that doesn't move, and it will be like the wheel is attached to the car without any suspension again. The damper is basically how much force is dampened on every repetition. So every time the wheel goes up and down, how much force is lost on that. So the higher, the better the damping. But once again, if that's too high, it will not work and the suspension will be awful. The target position is basically, so if you have this wheel here, that's the suspension, how high or low you want the suspension to be. So if this is the highest point, if there's no force attached to it, and this is the low point of the suspension, so like this, 0.5 is right here. So you want to find where you want the wheel to be. Here, this is where the wheel maxes out, and this is where the wheel has no force. So to simulate the weight of the vehicle, you want to be about 0.5%. So actually, let me show you how that looks in Unity. So if you go to the game, you just change this from 0.5 to 0. You can see that's basically the vehicle being on the starting point, like has no force on the suspension. And if you put this to 1, it will be like the suspension is all out. So there's no suspension here. Yeah. So the final thing we have in Unity is the forward and sideways friction. So in the universe, every item has a friction force. When 2 objects rub, there's friction between them. And the simplest way to see this is with this, where F is equal to the friction coefficient times the force. On the wheel, on a normal tire, this M can be something like 1.5 to 3. But this doesn't tell the whole story, because there is this thing where when you have an object, there's a difference between whether it's statically and hasn't started moving yet, and if it's slipping. If it's slipping, the force that's being applied is a lot lower than if it's not slipping. So as you can see, this is how much force is needed to keep the wheel at the same place. But if it starts slipping, it needs a lot less weight. You can't really see that because you cannot obviously feel the wheel. But trust me on this. You can actually take something like your phone and try to move it with a little bit of force. You'll see that it requires a bit of force. But if you throw it, it doesn't require like any force at all. It's like in the ice. So that's what we want to simulate here. So to simulate this, we have the sideways and the forward friction. In Unity, there is this curve. That's the force to slip extremum curve. So we have the force that's being applied times the slip, and so earlier I told you about the F is equal to F times N, but that's not actually the case. Force is actually based on the slip that we have, where slip is how much the wheel is slipping from where it's touching. So if the wheel is not slipping at all, we will be somewhere here. If it's slipping a lot, then we will be somewhere here. Whereas the asymptote means the line that's near this, but it doesn't touch. So when the wheel is not slipping, we have the force that's going to be 0 because it's not moving at all. But if it starts moving and it hasn't slipped yet, it will have the maximum amount of force that's going to be applied on the road, and the wheel is going to be pushing the car. That's going to be our extremum value. So we will have our extremum value and our extremum force. Sorry, our extremum slip and our extremum force. Our extremum slip is this thing here. This is going to be extremum slip, and this here is going to be the extremum force. So in Unity, this translates, if you'll see, there is this thing, these two here, the extremum slip, the extremum value, the asymptote slip, and the asymptote value, which translates on these things here. So this is the asymptote slip again, slip, and value again. And if you want to emulate a normal car, the extremum slip should always be lower, and the extremum force will be higher than the asymptote ones. So let's see what each thing does here. Let's try this. The normal car is should behave like this, from the older tutorials I had done. But if we increase the extremum value of the forward friction to about 5, you can see that the car is not moving as easily, it's not slipping as easily, because it has a lot more force used on it. So we can actually change the sideways friction as well. So if we put the extreme value to around 10, that's a lot, you'll see that it will never slide. As you can see, the car is not sliding at all now, because the force is too high to brake. If we make this 0.5, but increase the slip to 10, or make it maybe 1 to be more easy, you can see that it's going to take a bigger step of slip before it starts losing the real wheels. So to recap on this, because that's actually pretty hard to understand, we have the forces that are based on how much the wheel is slipping, and on a normal race car, you want to have this extreme force as high as possible, and to have as broad of a slip range as possible. So if you can make the curve look like this, that's going to be great if you're a racer. But to make a drift game, for example, you would want to make this be as small as possible and as close to the asymptote as possible. So when the wheel is sliding, to have a more predictable.
That makes sense, I think. Now we get to play with it, because I have a better idea of how this works. So if we take the 2 front wheels, oops, wrong ones, these two. These are the 2 front wheels, right? If we say that we want the sideways extremis slip. Wait, the what's he got as his
sliding,
value?
because that's and that's close. How maybe if you want to be more easily, you can see that it's going to take a bigger step of slip before it starts losing the real wheels. On the normal,
Okay, he's got 10. So if I say 0.5 maybe. So that's gonna make it so we don't slip sideways as much anymore. Do, 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 do. Hey, this is actually working. Okay, there we go. And we should probably increase the back wheels too. These are currently there, and maybe 0.3. What did I put this as? Yeah, 0.5. Then the slip value.
normal race car, you want to have this extreme force as high as possible.
So the
and,
value is force. And the slip is when it starts to slip.
Have as broad of a slip range as possible. So if you can make the curve look like this, that's going to be great if you're a racer. But to make a drift game, for example, you would want to make this be as small as possible and as close to the asymptote as possible. So when the wheel is sliding, to have a more predictable sliding, because that's unpredictable. Because when the wheel loses slip, that's going to become unpredictable because you will not know how the car will behave when slipping. And then something that I kind of forgot to mention is that there is the forward and the sideways friction. That basically means how much the force is when it's going like this. This is forward friction, and this is sideways friction. So if a car is moving like this and it's sliding, this is forward friction, this is sideways friction. Yeah. And the final thing that exists in the wheel colliders is this thing here that's called the stiffness. The stiffness is basically the easiest way to modify how much how much force is going to be applied on the wheel. So basically, if you want to change the wheel force based on if you're on a grass, if you're in glue or in ice, you can change.
Okay, so this value here, if I say 0. If I say 1, what's that gonna do? It handles better. It feels like I'm driving a boat though. But some of that's because probably because of the camera. Okay, so if I take this and I grab the camera and I bring the camera out like this. Click here. Here's our camera. Wait, that's not the camera that I wanted. Was it the main camera? Yeah, there we go. All right, and we hit play here. I think the camera ends up being a little bit nicer. Oh no, I haven't. This isn't too bad. We're definitely going to need to figure out better. One, I need to bring down the center of mass. So it's going to be negative on the y for that. The up is, yeah, that's what I thought. Vector 3, 0 minus 0 0.50. If we say create a vector 3 with 0 0.5 in the y-axis. Okay. Center of mass, offset. I think maybe we, okay, I have a better idea. I have a great idea. Yeah, okay. So all we need is a vector, right? And so if we do this, we do public transform center of mass. There we go. There, and if we load this, we come into here and we add a empty, create empty, center of mass. And then we do, oops, go like this, center of mass there. Then we grab this, and that's not quite where we want it. We want it more like right there. Be like right here. There we go. It's capable of turning on a dime. Okay, I've gotta move it back a bit. Maybe more Z0. Wow, that's a yeah, no, that's a lot of steer right there. Edit key. Oh, maybe 35. No, that's definitely better. Then we're going to take the front wheels and I'm going to move the front wheel in to be about the center of the wheel because that's actually where the offset's supposed to be, apparently. There we go. And hit play, and now my wheels should be in the correct spots. Ah, that looks better. The handling feels better. I gotta work out the camera still. But that's we're definitely getting there. Where is my camera? Camera controller. Why is it not following the way that I want it to, though? Here's my player rigid body. Camera remote location. There's the player transform. There's the offset, which is not really what I want. I think this would just be this. And then we would set the rotation. Set rotation to player rotation. Uh, let's see if this works. Okay, so it gets set, but it's not updating. So this is not working. I feel like we could just do this, and then if we do look at player, and then we just do position equals camera location. Location dot transfer. If we just do this, Could this just be position? There we go. What will this do? I'm aware that this will not be perfect, but it will get me somewhere there. Let's see what this looks like. So late update is not firing at all. Beautiful, beautiful. I don't think it's firing. Unity late update. Does this need to be private? Just says public late update. Let's do this. Debug.log late update camera control. Yeah, late update's not firing. Cool. Unity 6 late update not firing. Code is executing for earlier. To achieve a late fixed update effect. Not. Not executing. Not being called. Yeah, it's wait, maybe it didn't build. Okay, let's see if it starts firing now. Oh wait, that's why. Why is it not executing? Well, because you don't have it executing. There we go. That's fucking great. It's very capable of flipping at high speeds. I have to decrease the steering, I think, at high speeds or something. Or I need to have more slip. Maybe a little bit more down. Oh, you know what? I'm using a plus. I think I need to do a multiply. Vehicle controller for the center of mass. Wait, no, I'm not using that at all. I'm just doing that. Okay. Let's go back to here and we're just gonna grab the center of mass. And we're just gonna move it down even further and hit play. There we go. Center of mass is in a better spot now. Wow, I'm slipping all over the place. We're gonna have to fix that. But progress is being made. Progress is being made. Okay, do that's good. Good. There we go. I'll be right back. Okay. Let's get back to this. Okay. Let's remove the debug log in the camera control. We'll change this later because, yeah. And then this here, I think we'll do transform look at, and then we'll just say player. I have the weirdest goldfish cookies. I didn't realize that they made like proper biscuits. I think they're biscuits. Box 3, camera 7. Oh wait, that's the French side. Oops. And they're goldfish. No, it's not going to focus properly. It's fine. They're not bad. Okay. Unity speed in kilometers per hour. Unity It's in units a second, so if you're testing 1 unit equals 1 meter, then it's meters per second. Unity, how to figure out what 1 unit in Unity is 1 meter, so it's meters per second. And then 1,000 kilometers. If I'm not mistaken, is 100 meters is 1 kilometer. Or sorry, 1,000 meters. Kilometers. Yeah, that's what I thought. So if I display, is there a way to like actually screen debug? Oh, I forgot to change this back. Sorry. Unity screen debug. Or Unity print to screen.
Let's see how to display text on screen in Unity. For that, we need an object that can render the text. In this case, we'll use the text component of the canvas. Right-click in Hierarchy, UI, and choose the first option, Text. Before moving forward, I will configure the canvas scaler. Select the canvas game object, and here in the canvas scaler, set the option Scale with Screen Size, and set the reference resolution in 1920 by 1080, which is the resolution I'm currently using. Now I will configure the text component a little bit. Adjust the size, center it horizontally and vertically, increase the font size, and with this we can start working. Here we need to differentiate a little bit between objects, because they all have the same name, text. This text here, listed in the hierarchy, is a game object. This game object has assigned a text component, this component here in Inspector. Within the text component, we also have a variable called text, which stores the text to display on the screen. Then, if we want to modify the text on
Is that seriously the only way to do it? That's so terrible. Okay, so it's just debug log for now. Okay, fixed update, speed. And we will do a debug.log. Rigid body dot linear velocity dot magnitude. Okay, and then we'll build. And then when we hit play, we should see our linear velocity. Okay, we're definitely going faster than 14 meters per second. This is not 25 meters per second. Unity, how many units is one box? One box is typically 1 unit. Okay, that's what I had a feeling. Figure out the size of an object with Unity boxes. Wait, if I go like this and if I grab these cubes, is there a way to duplicate these without having to like just do the whole Control D? I feel like the answer is no. Okay, and then I said it was here, right? There was a way to do this for orthographic. Unity put camera and put go to
Hello everyone and welcome to Plus Equal one for this lesson. Duplicate the cube and move it. Okay. So the camera is here.
Oh, that's where it was. There you go. Orthographic. So this is 3 units. And how tall is a Isuzu Elf truck? 2 meters. So this is taller. No, that's about it. Yeah, that's like 2.5. Okay. So it's about 2.5 is what I've got, and that seems reasonable. How tall is a Isuzu Elf cabin? Yeah, it was right. Approximately. Okay, so it's about right. Unity, um, kilometers per hour. Measured in per second. Oh, okay. So we take this and then we do a quick multiplication on it times. There we go. And then we go to perspective. And we take these and we move them up. And then we can see what our kilometers per hour is. That's more like it. 30, 40. There we go. How fast does this thing start going? I don't think this has an upper limit of how fast it can go. Yeah, there's no upper limit for how fast we can go. It'll just keep getting faster and faster. Okay.
Change this for easier physics. So if the stiffness is 0, it basically means that there's no friction.
Let's see, AI car controls in Unity.
Tipping over. So to fix the brakes, we need to get the angle of the wheel that's moving. So basically, when a car is moving forward, you need to check that's actually moving forward, not backwards. And you need to do that by checking its angle against its velocity. So this is the forward angle. So when it goes forward, it goes like that. But the velocity angle can be like either matching or it can be moving. So if it's going sideways, it's going like this. This is going to be the difference. And as you can see, there is like a 30 degrees angle, which we call it the drifting angle, not split angle, I guess. So we need to check that's actually more than 120. And if it's more, then we will reverse the car. If it's less, then we'll apply brake pressure. So okay, let's do that. So we will create a new variable, which we will call brake power. And we will also create a private field, which we will call a slip angle. And we will actually monitor that. So to monitor that, the slip angle will be the signed angle. So the signed angle of the player. So our transform dot forward, which is basically the forward vector of the car, which does not change no matter how the car is moving. And our velocity vector, which is basically where the car is going. So if the car is going like this, and it's looking for like, so it's slipping, it's going sideways, our velocity will show the sideways motion. So we will go to our player body dot velocity. Okay. Yeah, so we need an axis. So it's basically at what dimension we calculate the vector from. So because we're basically looking from the top down bottom to see where the car is going, the axis will be the vector theory dot up. Okay. So now if the slip angle is more than 120 degrees, so so if it's less than the 120 degrees, so if it's going forward, and if the gas input is lower than 0, we will actually set the gas input as equal to 0, and our brake input as, oh yeah, we need the brake input as well, forgot that, as the gas input. Sorry, yeah, so brake input is equal to our gas input, and then we reset the gas input. Okay, so this brake input, we will use it on another function, which we will call it apply brake, which we will apply brake. So we will apply the brake on all the wheels, but a bit less for each wheel. So the front wheels will be around 7% of the braking power, and 30% will be the back. Since the car, when it's going forwards braking, it's naturally pointing the nose down. So okay, let's do that. So we will go to the colliders. Dot front right wheel. Dot brake torque, which is different from motor torque, will be equal to our brake input times our brake power, and we will do that for each wheel. Okay. So front left wheel, rear right wheel, and rear left wheel. If I click it, okay. But this will be around 0.7 our brake power, 7 again, and I forgot the F for float. And this will be around 0.3 floating points, and 0.3 floating points. And let's check it. This should work, and it should break. So let's check. Okay, it's not working. Why is it not working? Oh yeah, so we don't have applied this. If it's yeah, so else the gas input will be so the brake input will be 0. Yeah, it's not working because I did not make the brackets correctly. Okay, so let's check it. So the car controller, we will increase the brake power to something like 50,000, since the brakes produce a lot more power than the motor. So let's check if this works. Okay, so it's moving forward, and if I press the brakes, it does not brake. It doesn't brake. So let's check that's not does have something to do with the values. What have it? Yeah, it does not have something to do. Yeah. So the problem here is that we are actually having a negative brake input, and the brake torque does not take negative numbers. So to fix this, we will basically just make this get its absolute value. It's pretty easy. Let's check again if this works. All right, so this works, and it still doesn't brake. Okay, so let's check if the gas input is lower, so that, oh yeah, so once again I forgot to apply the brake function. Okay, let's do this now. This should work. So, okay, this brakes. As you can see, that's actually the braking motion. So it goes forward and it stops. That's the perfect stopping motion. And now it doesn't go backwards because it does not know that when it's not moving, the vector can be forward, backwards, can be anywhere. The velocity does not change. So we do not have steering angle. So to fix this, we can actually just make the player velocity to be the vector. So if it's 0, to be negative. So we actually we add the transform forward position, but actually the transform backwards position. So when it's the velocity 0, we can actually detect that the sleep angle is negative. So let's actually check if this will work, and it should work. It shouldn't not work. So let's say, okay, it still doesn't go forward. Yep. Okay. Actually, let's check the sleep angle of this function. Okay, so the sleep angle is oh yeah, I have actually no idea why I put the sine angle, so it's not the normal angle. So we do not need the vector up, it's basically just an angle. So let's check it once more. Okay, it goes forwards and it still doesn't go backwards for some weird reason. Yeah, because we have not reset the brakes, so we need to reset the brakes outside the sleep angle. So yeah, let's do this. Keep the other one as well. So I think this will work. Okay, so going backwards, perfect. And now it goes forward, brakes, and goes backwards, perfect. So let's check, it works, it goes left, right, brakes, and goes backwards, perfect.
Interesting. I thought I had his stuff pulled up here. Why brake? Brake input. Gas is pressed. Oh, this is how. Okay. 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 I see how this is working. Kind of like that, yeah. Yeah. Okay. What did he say this in? Check inputs, yeah. Accelerate. We're gonna just say check inputs. And we're going to just do this. If gas pedal is pressed, which we can do by going like this, is gas pressed? It is brake pressed? There. It's going to break a bunch of things, but if we come into here, right, this is the context, we can just say is gas pressed equals true, and is gas pressed equals false, right? And then we can get rid of all of this extra stuff here. And then we can actually just do this. We can do is gas pressed equals, so we don't have extra stuff that we want. So we can just do this. And then down here, we'll just do the same for is brake pressed, and then we'll just do that. Then we can do this. We don't need the gas input. This would be is gas pressed. Is brake pressed. And then in here, we would do gas pedal equals, this would be a float, I believe. Gas pedal. Where's our current gas here? Accelerate. I think it's in here. Yeah, this. Hmm. I'm actually going to change that because I want to not have that as the thing. Okay, so gas input is just a float. Where is it being used? It's being used outside of this. Okay, yeah, it's being used all over the place. So this would be here. Public gas. Because these are both the, yeah, okay, but he's still got the brake input. Okay. The steering is going to be an interesting one. And that's in get access. So all we have to do here is we do public float steering input, right? And it gets rid of that, but this isn't correct here. This needs to be to do the steer. Apply steering is this. Input actions dot player dot steering dot read value float. If steering input is greater than 0, if steering input is less than 0. I don't actually know which one it is right now. So I can find out though. Left is negative. positive. Yeah, I got it right. Left is negative, right is positive. There we go. And then we can do this. We just do this. And this is just equal, and this is equal minus. How is gas input being used? Okay. I don't like the here having these be on the same here, but for now I'll just leave it. It doesn't matter. If you've got it pressed down, then you might as well have access to, you know, like it might as well break. But this here, say gas input equals, I think we just do this. Yeah, and then then we just need this. But then we don't even care about this. Because we can just, if this is 0, then we're just adding nothing, right? Slip angle. Okay, so now we've got the steering. And we've got that. Okay, then slip angle. This would be rigid body. Rigid body dot linear velocity. Get the, this will be a, I think this returns a vector. Vector 3. Const vector 3. Forward. Will be a forward vector. Fixed code to break even after going on reverse. Hi, Andrew, Alex. Fixed code to break even after going on reverse. Okay, so move direction here would be the dot product between the forward vector and the linear velocity. Vector 3. So t equals, or we'll say current velocity. Current velocity equals rigid body dot linear velocity. If I'm not mistaken, this finds the difference. Two vectors. Let me just refresh myself on what that is. Vector dot product. In Mathematica, this or scalar product is an algebraic operation that takes two equivalent length sequences of a number. Right. It's the direction based off of two points.
Professor Dave again. Let's find dot products. He knows a lot about kinds of stuff. Professor Dave explains. We now understand what vectors are, and we can do some operations with them. We can add and subtract them, and we can multiply them by scalars. But we also want to be able to multiply two.
Pause 0.
Two vectors together. And this is
What's up,
not as trivial
man?
because we have to understand what we mean by this operation. There are actually two different ways. A1 scalar product.
If I'm not mistaken, the properties of a dot product. Yeah, so it'll give me the difference, right? Which will give me the direction I'm currently moving. If gas is to do. That does make sense. What are you even doing? Slowly fixing the vehicle so it feels better to drive. His apply brake is weird. Yeah, car physics. So he's in his update, right? He's got his brake. Oh yeah, you haven't seen the game as it is right now. One sec. Let me quickly fix this. I'll show you where I'm at now. I've been working a little bit on it. As you can see, we're getting places. Okay, that was definitely a thing. So I've got better steering now. Steering's better. Center of mass is a little bit better. Because I'm not just like computing it. I've actually just got an object that a empty object that dictates the center of mass. But this started to feel a lot better. And I've started getting the oh, this already feels so much better. Yeah. So car physics. Car physics more than meets the eye. And then I've got my world that I brought over from Unreal. It doesn't have any of the collisions. I spent 12 hours trying to have it generate the collisions, and it is not a good idea. So I'll come back and I'll fix that later. So this is sort of the map from Unreal. It is by no means perfect, but like it's not a perfect representation of the map from Unreal, but it is kind of there. The Unreal map has a couple extra meshes that this one doesn't, and it's just because I didn't want to bother bringing them in yet. I've got a question for you since you know Unity way better than I do. How does Unity do baked lighting? Because in Unreal it does it on the UV2, right? So all of your UV maps need to have 2 UVs, one for lighting and one for texturing. Oh yeah, no. Yeah. I totally did that and it is not a great idea. 12 hours later, it was still generating. There's a lot of meshes. It did not like that. So maybe I'll try again when I log off for the day. But yeah, these are kind of not great meshes anyways. All of these are going to be replaced. I have custom collision meshes that I wanted for the buildings. So I've just been building those as I go. Okay. I'll have to look into it. Because I'm going to be using the idea is to have you use trim sheets, and if you're using trim sheets, you can't use those UVs for baked lighting. You have to use different UVs. But the car's starting to feel better. That's really nice. There we go. Yeah, you can't use trim sheet UVs for baked lighting because you run into the issue of like everything is skewed and all over the place. Things could be like really small or really big, and nothing's right if you do it. So hopefully it's just like a separate UV. But this is feeling better already. I gotta say it's taking less time than I expected to get this up to here. Yeah. I'll figure it out. The city part. I just figured I'd slap it in there to get started on it. May as well, right? I've already got the city. Like I've got the city that so I can just bring it in because I've been working on it in Unreal. So fucking ads. All of the chat's not working today for some reason. For that bottom. Yesterday it was just YouTube, and now it's YouTube and Twitch. So I'm gonna probably stop using that chat system, that chat overlay. Welcome back. That's totally pretty much what this is. Except for it's from the Unreal Marketplace, which is, I think, actually from Sketchfab, because it's from Fab specifically. Like it wasn't in the Unreal Marketplace. It was in Fab. It came. I think it came into the UE Marketplace with Fab. Okay, so I don't. I think once I start reversing, I cannot go forward. Yeah. Well, okay, so I'll show you the Unreal project, and it will kind of give you an idea of like what I'm doing. But I'm gonna go find some lunch for something for lunch. I'm starving. All right, have a whole level. So did you find a model that had walking? Oh, I don't know. Maybe. So this is the level that I brought in. But without my changes to it yet. As soon as this loads. Yeah. So effectively it is this map, but some of the buildings have been replaced. So I've got this building, this building, this building, and this building done, as well as these have been replaced by custom ones. And then I've got Hachimo, the Hachimo statue, the dog. He's in place. Yeah, the end goal would be to replace like all of these buildings with better meshes, because like right now, if I click on this and I move this, right, this is absolutely not what we want to see. Right, like those are not good collisions. Um, they're overly bad because there's so many pieces. Like right here, if I grab like this, these are boxes, and they're like a lot of boxes here. Like this is a box. This is two boxes. Yeah. I don't know where to begin for adding walking, to be honest. So I'm not going to worry about it for now. I just wanted to be able to like hit them and they go flying. I can have them run around in T mode for now. T pose for now. That's fine. Well, bam. There we go. And then weight of a woman in Japan. Hey, I got it about right. I think I made her. I think I made her around 60 kilograms. She's a little on the heavy side, but I think that ended up being about right. I think this model has animations for walking though. But we can check because I think it said that it had animations. Ooh, there's a scene. Oh, no. I don't think these have any animations. Do they? Do they not have animations at all? No, I guess not. Ah, well. Oh, here we go. And this is the same level, but in Unreal. So here you can see my custom buildings. And everything has collisions. And this is kind of where we're trying to get back to. So I actually went through and like modeled these. Modeled this one and this one and this one and this one that I forgot to apply the collisions to. And then there's this here, which is the oh, apparently there's no thing on that. LAPD, slow. You'd have to ask Torque. Yeah, there's the Hatchimoth figure. Torque's working some stuff out with that. LAPD? LAPD is Torque's doing the art and environment and all of that wonderful jazz. And he's the effectively like he's doing all the planning, and I'm just doing the programming for it. But he's not really at a point right now where I can do much. So I'm just working on something else in the meantime. Still have the files though. I have not deleted the files. But this one's Isekai Crusader Truckoon's Realm Rescue. And this one I'm porting to Animated Trucking Kitnet. Yeah. Amazing. I gotta admit, I absolutely love the way the ragdolls in Unreal work. Just like out of the box, they feel a little bit more precise than the Unity ones. But with that being said, you need to like enable them like way earlier, or else you run into like enabling ragdoll in Unreal takes substantially longer than Unity, which is kind of interesting. But they don't like, the Unity ones seem to like by default they kind of like go all over the place a bit more. So I'll have to do a lot of tweaking on that. It's stoppy with a truck. Big drift, yeah. And then this is the new version that I'm kind of working on. Oh yeah, the brakes on that truck are insane. But and then I've got to adjust the camera probably, but you can see how it did that weird thing where it like stretched out. And I think that has to do maybe with the way the not the collisions, the they're connected. I don't think they're connected entirely correctly, so. Anyways. And then this is the Unity project so far. It rocks so much more. Like, but I think that's because the suspension is probably much higher on this than it is on Unreal. So we get a lot more rocking that way. So I might have to adjust that. That actually might be something worth adjusting. But we've got fairly decent brakes, I think. Maybe. I think our braking power needs to be increased. We don't brake fast enough. Braking torque. But getting used to Unity is a bit of an odd one. Mhm. Okay. We're gonna close out of this and we're gonna go back to here. We don't need to grab this again. And then we do want to come back to, where is it? This one? Yeah, this one. And if we come down here, we can do apply brake. How is apply? Okay, brake input. But where's brake? Oh, brake input is here. Oh, else 0. Do I have that? Okay, yeah. And then if I just grab his brake, apply brake. Here we go. And just do this. And then this would be for each wheel collider. Not motorized wheel. Wheel controller. And wheel controller in wheel controllers. Wheel controller dot dot wheel collider dot brake torque equals that. And then we don't need this. And if we come over here, we can do, this is the motor. Let's go to do apply, accelerate. This is going to be, we're going to change this to apply brake. This will be for each wheel controller in wheel collider. Sorry. In wheel controllers. Wheel controller dot wheel collider dot motor torque. There. Actually, this needs to be wheel collider, and then in motorized wheels. Motor torque. Apply steering. Apply wheel position. Don't care about that right now. Update wheel. Where are we here? Apply steering. Yeah, that's fine. Then here it would be check inputs. Apply steering. And then I think we're good to try this. It's so good. Okay, so it's the motor torque is not high enough. Okay, interesting. Let's see. Apply motor. Okay, that is what he's got for apply motor. Excuse me. Interesting. So this would be gas input. Yeah. Okay, so if I go to here and I hit play, what is our gas input? Gas input is nothing. It never changes. Okay, so gas input never changes. Great. Perfect. Check inputs. But these here are what we want is gas pressed. debug.log gas rest. Oops. Break rest. Oh right, I forgot to remove that. I don't need that log. I don't need the speed log. Mm-hmm. Okay. Okay, so it is triggering that it is being pressed. Should I just do ×2? Wait. Gas input and brake input are the same, right? What if I do this? Oh wait, no. One sec. Okay, so I hit play. Let's see. Okay, so I hit play. We can click on this, right? And then we can see that our gas input is 0. It's still 0. Brake input actually gives us a value. Gas input is giving us nothing. Okay. Oh, right, because wait. Accelerate, right? I wanted to change that. On gas. Okay, let's make sure that we still get the on gas logs. There we go. Beautiful. We're still not getting anything on the gas input. So that's fun. So the next thing that we want to do is we know that this is being hit. So we can get rid of those logs. And what we want to do is we want to come down to check inputs, and we want to say debug.log gas input. And this will just allow us to view it to make sure that if it's swapping to 0 really fast, we're not missing anything. It's 1. So something's causing it to, at some point, we're switching it to 0. Okay, so gas input here, and then if I go like this. Oh, wait. There we go. I found the problem. There we go. Now I need to do a gear system at some point. Whee! Okay, sweet. Stop. Let's open this, and we're going to say e-brake. So we're going to add a new one. E-brake. This would be listen for this. Then we're going to add a new binding, and we're going to listen for space key. Keyboard and mouse. There we go. Then we can save asset. Beautiful. Come back to here. And then we would say is e-brake pressed. There we go. Where is the brake? Apply steering, apply brake. Here we go. And then we've got our brake torque here. So what we're going to do is if we're going to say float current float current brake torque equals brake oops, not brake torque if is e-brake pressed, current brake torque multiply equals 2. And then this becomes current brake torque. That should give me even more stopping power if I slam on the e-brake. Yeah, it's totally not working. What the fuck? Oh, right. I forgot to set it up. To do events here. Object of player. Hey, there we go. Okay, so there, and then if we come to a fairly abrupt stop. But if we go from here, let's get this up to maybe 30. And then we slam on the e-brake and it does nothing. On e-brake is never used. It should be used. I just set that up. Oh no, that's on brake. Oops. On e-brake. There we go. All right, we should have a very abrupt stop. Okay, let's get this up to 30 on the speed. Okay, it's still not working. That's super happy good fun times. Okay, let's go back to here. And debug.log e-brake. I'm going to run this again and see if it works. Well, bam! Look at that. Okay. What the hell? E-brake is like just never used. It doesn't apply my e-brake. If I do that, maybe? Oh, wait. That's why. Gas input minus equals input action dot player dot e-brake dot read float. There we go. I'm slowly getting there, you know. one line of shitty code at a time. Yeah, there we go. That's much better. I wonder what happens if I do this. Will it go backwards? Yeah. Okay, so if is e-brake pressed, if not is e-brake pressed, do this. No, wait. We need to go somewhere for the where's the reverse? I think the reverse is in the backing. Where are we applying the gas? Right, we're applying it on apply gas. Sorry. If is e-brake pressed, we want to return. Not entirely sure that this is correct. Okay. We're gonna see if this works. I don't think it's gonna work properly, but I could be wrong. Oh no, it does. There we go. That's perfect. That's exactly what we wanted. Interesting. If I apply both the e-brake and the brake, then that happens. If I apply the brake and then apply the e-brake, we get that. That's kind of weird. So here we're going backwards, and then I apply the e-brake and we get nothing. Right? if gas input, oh, wait. If e-brake is not applied and gas input is greater than 0. No. If e-brake is applied and the gas input is less than 0, return. Or, no. Yeah, or. No, it needs to be an and. Because if it is and, not or. Okay, so we're going to get it up to speed. We're going to apply the e-brake. We should see it stop. There we go. Nothing. We're going backwards. And we're stopping. Oh, wait. Float. Current torque equals times gas input. Right? If is e-brake pressed. So what we'll do is we'll take this, we're gonna move it up here. We're gonna do that, and then if this, there. If not e-brake, and do that. No, I think what we want is this. And then if is e-brake pressed, we want current torque to be 0. And then down here, we want current torque. Now we only do this calculation once. We get a little bit of performance. Okay, and this should apply the brakes still. We don't move. We're moving backwards now, and we apply these. We're not applying the brakes. I love it. 10 out of 10. um, if is my brake. Oh, wait. Okay, wait. I know what's going on here. Break input equals 1. No, because this will still give me a break input. This should give me I think no, because if I have this at 0, then it doesn't matter. I'm gonna have to come back on that. For now, this is kind of fine. I say kind of fine, but whatever. What we could do is this, right? But we should probably do this. If not, give me a second here. Then, if not this, we take this and we apply this. There we go. And then else, we want to take this and we want to say brake torque is going to be just one sec. And then if we go to apply gas, if we do, if not, we do this. Else, we do this. I think this should get us to where we want to be. Why is it at -1? Uh, okay, apply brakes. Okay. This makes sense here. Else if is e-brake pressed. Brake input equals this. Oh, wait. I know. Or is e-brake pressed. There we go. Give me a second. I forgot to put the bars here. There. Now we don't need any of this extra stuff. So yeah, we don't need any of this anymore. Oh no, we do. Maybe? No. Because e-brake should never lead into actually going backwards. There we go. That fixed it. Oh. I don't know if 2 is necessarily enough. Like we're multiplying it by 2. But maybe 4 or something like that is better. Hmm, 2 seems pretty decent. I just have to figure out how to get this to be less rocky. And I think that's the suspension. I bring the center of mass down even a little bit further. That will probably make some good changes there. Let's see. Does it rock less? Yeah, it rocks less. It's a whole lot stickier. Still get a little bit of rocking, which is perfect. We do want some rocking. But the center of mass should be lower. Yeah, there we go. Maybe it's a bit too low. Feel like it's a bit too low. I think it needs to be a little bit higher. That might be a little bit too high. Yeah. We're rocking a bit too much there. Mm. Do, 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 do. Okay, that feels better. I think I like that a bit more. Whee! There we go. Ooh. Ugh. All right, so the vehicle is good enough for now. And now we can get into dots.
In this video, we're going to cover Unity's new data-oriented.
Hello and welcome, I'm your Code Monkey. Let's learn how to get started using Unity Dots. This is a technology stack that can provide some insane performance results, literally 100x faster in some cases, and thankfully learning the basics that is actually pretty simple. Here let's learn what is a component, what is a system, and what is an entity. Then we're going to learn how to create a job and run it with the burst compound for some insane performance, and also see how to combine both entities and game objects and interact with them back and forth. This video actually turned out pretty long because there's so much to cover. There's timestamps throughout the video. I've been researching all the documentation and working on this video for the past 2 weeks, so if you find the video helpful and you're feeling generous, go ahead and drop a super thanks on the video, or simply hit the subscribe and the like buttons. It's a small thing, but it really does help, so thanks. Also, huge thanks to Danny from the Unity Dots team who helped me by answering tons of my dots questions, so this video could be as accurate as possible. Now over here on this video, this is going to be a technical tutorial on how to start using dots, but if you're looking for a high-level overview on the theory behind what is dots, what is ECS, and so on, for that I highly recommend the video from the channel Turbo Makes Games. That one is a really excellent explainer of all the components that make up dots, as well as the pros and cons and when to use it and when not to use it. So go ahead and watch that video for the theory, and over here let's learn the technical part on how to actually use it. Although let me also quickly remind you that you don't have to go full dots or full game objects. The ideal workflow is to mix them both. So dots is really just another tool in your toolbox. It is indeed a little bit more complex compared to game objects, as we're going to see in a little bit. It is an advanced tool after all, although it's honestly not really too complex once you understand the basics. And of course, that complexity actually buys a ton of excellent benefits. So even if you're working on a relatively simple game, I would still encourage you to watch this whole video to the end. Just to be aware, just remember that you have this tool at your disposal in case you need some excellent performance at some point in the future. You don't have to use it for everything, but for some cases it is an absolutely excellent tool. And also just a question for my own purposes. I would love to do a complete dots course in the next few months. So let me know in the comments if you would be interested in that, and specifically let me know what type of game you'd like to see made. Now the obvious answers would be a factory game or an RTS, but could also be tower defense, third-person shooter, vampire survival like something like that. There are plenty of genres where dots makes a lot of sense. So do let me know your thoughts in the comments. I'm currently working on a complete C# course, and after that one I plan to work on a dots course. Or if you're watching this several months in the future, maybe I've already done it, so check the pinned comment. And if you use Unity at all, then check out my Ultimate Unity Overview course and learn how to make better games faster. It features over 70 lectures, each covering a different tool or feature of the engine, including many of which you might not know about and might be super useful for whatever project you're currently working on. Okay, so let's begin by making the most basic demo possible. Let's make just a simple cube rotating. Now before we do that, just some notes. In terms of Unity version, over here I'm using the Unity 22 LTS, although you can also use the 23 beta if you like, it should be pretty much the same. And if you're watching this many months or years in the future and using Unity 6, then it should still be mostly the same. Then dots uses a lot of source code generation in order to simplify various things. So for that, you need to be using an IDE that supports that. In my case, I'm using Visual Studio 22, the free community version. And then they also recommend that you modify the domain reload setting. So for that, here in Unity, let's go into Edit and then Project Settings. Then on the left side, go into the Editor tab, and over here, let's scroll down, find here the Interplay Mode settings, and let's enable these and make sure these two are unticked. Now, importantly, you should know one side effect of this is that your static fields and events, those will not be reset by default. Meaning, if you set some data on a static field, then you stop playing and start playing again, that data will persist. Whereas if you have domain reloading enabled, if so, it will always clear the data before starting. So just be aware of that side effect, just be aware of what this option does, and when working with dots, be extra careful about any static fields or events. Alright, so here in the editor, let's begin by installing the package. So as usual, let's open up the package manager. Up here top, let's go into the entity registry, and then over here, let's scroll down and find the entities package. Alternatively,
Okay, let's start enabling this. So window, package manager, and then we do entity. Wait, what? Oh, there it is, entities. There we go, and then we install. Wait, what's... Wait, one sec. Entities package provides a modern Unity component, entity component system implementation with a basic set of systems and components made for Unity. Then entity graphics, I'm assuming, is something else that I'll need. I don't need the netcode because we're not making multiplayer. Although I think I might be able to, like, I think that's mostly handled, right? My understanding is that the entities net, the dots netcode is really good. Let's see, entities graphics package provides systems and components for drawing meshes using dots, including support for instance mesh rendering and LODs. Oh, okay, so we want this. I really want to fix the light, but I don't know how I would do it. I think it would cost money to fix the lighting. Ugh. There we go. That didn't fix it. Damn. Sorry. I effectively need like a bunch of paper just to fill that section of the window right now to get rid of all of the streaks that are driving me batty. Okay, so let's go back to here.
If you don't see it, you can also install by name, so com.tnt.entities. You would basically go up here on the top left corner, add package by name, and put in this name com.entities. But as long as you are using a recent version, you should be able to see it, so let's just go ahead and install. Okay, it's done. Now the other one that we need in order to be able to render things is the entities graphics. You only need this one if you actually want to render entities, meaning you can use just entities without any entities visual. But over here in this demo, I will indeed be rendering some entities, so let's go ahead and install this one as well. Now, one more note related to this, entity graphics, this one only works with either URP or AGRP. It does not work with the built-in render pipeline. So here in my project, I have my project set up to use URP, the Universal Render Pipeline, and I also recommend that entities rendering be used for plus rendering. So let's go ahead and set that up. So let's go into the render pipeline asset, and inside, let's go inside the actual render object. And over here for rendering path, let's put it on forward plus. Okay, that should do it. Let's also make sure all the other packages related to dots are also installed. Again, remember how dots is really not just one thing. It is actually composed of the entity component system, or ECS. That's the entities package that we just installed. But then it's also composed of the job system and burst. Those should both automatically be installed as dependencies. So if you look over here, burst, yep, this one should be installed. Then the other one is the mathematics library. Yep.
Let's double check package manager first. Yeah, and then what was the other one? Mathematics. Yeah.
Also installed. And finally, the collections library. Yep, also installed. Okay, great.
Collections. Yep.
So we have all the packages that we need. All right, now let's begin by making our first entity. And the way we do that is first we create a subscene. So over here on the hierarchy, click on the plus icon, and let's create a brand new subscene. Then give it some kind of name. So over here, entities subscene. All right, there it is. Here we have our subscene. Now this subscene, this is an ECS specific thing. Basically, any objects that we place inside of this subscene, all of those will automatically be converted into entities. So inside, for example, let's create a new game object, and let's go inside 3D and just make a basic cube. And yep, look how that one is indeed inside the entity subscene. And now this game object, this will automatically be converted into an entity. If we look on the inspector, and down here we can see something for the entity baking preview. You can click to expand this, and over here basically we can see all the components that won't be baked based on these regular components. Also, one very important thing, the system is smart enough to be optimized to only create entities when they are needed. So if we create a cube like this with these visual components, then it will indeed create an entity and add all of these components. However, if I go in the subscene and I create just an empty game object, if I do, yep, nothing shows up here because this one won't actually be baked. If the game object has no components, nothing at all, then it will not actually create an entity. So with the cube selected, another way that we can see the entity components is on the inspector on the top right corner, we have the circle button. And if we click on it, we can basically toggle the inspector between various modes. Right now we are seeing the default mode, which shows usual game object representation, so the usual components you're used to. And then if we click on runtime, yep, now here we can see the entity representation. So instead of the normal
The course CodeMonkey was talking about are out now, by the way, while RTS Dots course on his YouTube channel. Oh, is that actually what it is? Because he released it for free, right? Sort by date added. Pathfinding in dots. Are you sure it's out? Or maybe I'm looking at RTS. I thought I remember because I thought I remembered him like releasing it and opening it up, right? But then I also saw this and I was like, oh hey. But I think this is a paid course still. Yeah, it's $100. Oh, wait. Called Learn Unity. Oh, right. It's just it's a straight video, right? Yeah, that's what it was.
Hello
7
and
hours.
welcome, I'm your Code
There we
Monkey,
go.
and here's my awesome 7-hour free tutorial video all about learning Unity dots and making an awesome RTS. The fun game has lots of units, lots of buildings and zombies. It has resources, fog of war, ragdolls, destruction, zombie hordes, and tons more. In order to build all this, we're going to learn all about Unity dots. This is Unity's super performant tool stack. It can make your code run literally 200x faster. That is really insane. With this massive speed up, you can make more complex, more ambitious, more interesting games, or it simply helps your games hit 60 FPS much more easily, or helps keep battery consumption low on mobile. So this kind of extreme performance has a ton of really awesome benefits. We're going to learn all about dots, starting from the absolute basics, starting from literally what exactly is dots, what is an entity, a component of the system. Then we're going to learn what is the job system, what is the burst compiler, and what exactly is the syntax to build all this. We're going to learn about dots physics, how to handle authoring and runtime data, learn how to do all kinds of queries, and tons more. So we're going to start from scratch and learn each of these dots concepts one by one, slowly bit by bit, over the course of about 80 lectures. Now I worked super hard to make this course have a really nice smooth learning curve based on the comments from students. I did achieve that, but with that said, dots is still very much an advanced topic. This is not for beginners. If you are a beginner, then just stick with game objects and don't worry about dots for now. Just keep learning basics and getting nice foundation before learning about dots. For beginners, you can check out my free Kitchen Chaos course on making a game from start to finish, all with normal game objects.
I reject your statement, and I will learn how to use dots right now, even though I don't even know how to add animations to a character.
And then a second one on making it multiplayer. Alternatively, you can check out my free C# course if you understand everything in that course for both the beginner and the intermediate sections. If so, then you're ready to learn about dots. Or if you've gone through my turn-based strategy course, if you managed to go through that one, through that entire thing, then yep, you do have the skills needed to start learning about dots. So if you're a beginner, then don't worry about dots. But if you're not, if you're past the beginner stage, if you're in the intermediate or advanced level, if so, then yep, I highly recommend you learn about this really awesome toolset. Like I said, benefits are immense. You can run code over 200 times faster compared to normal game objects. This allows you to make more complex, more ambitious, more interesting games. So this is definitely a very, very powerful toolset that you should know how to use. Now in this video over here, this free 7-hour video, this contains the first 7 hours of the course. The full course is about 17 hours long. So if you want to get the whole thing, then check the link in the description. That one contains the full course alongside bonuses like obviously having no ads. Then the videos are split into separate lectures. It also grants you access to my private Discord and my private Twitter live streams. But over here in this free video, this still has a ton of knowledge. I made sure to include as much dots knowledge as possible over here in the first few hours, specifically to make this free video really valuable. So even if you can't afford the full course, you can still learn how to use dots completely for free with this video. I think dots is an absolutely awesome piece of tech. I really love what Unity built with it, and I really want everyone to be able to learn this awesome tech. It's going to be really interesting to see the games that come up in the next few years as people learn more and more how to work with this. So I'm really hoping that this free video helps a ton of people learn how to use this awesome tech. If you want to get the full 17-hour course without any ads to interrupt you and with all the bonuses, if so, then check the link in the description. But if you can't afford it, then that's fine. I hope you learn a ton from this awesome free video. And one final request, if you find this free video helpful, if so, then hit the like button and subscribe to the channel. It's a small thing, but it really does help. Alright, so with the intro out of the way, let's begin making an awesome RTS and learning all about dots. So let's start the course in the next lecture. Hello and welcome, I'm your Code Monkey. Welcome to my Unity dots course. Here we're going to learn all about dots, which is Unity's super performant tool stack. It requires us to learn a different way. It requires us to learn about data-oriented programming as opposed to object-oriented. So that requires a different way of thinking. And by learning this, we're actually going to get some
Is it not? No.
massive performance benefits. Those will allow us to make games with tons of complexity so you can bring whatever vision you have to life. And
If I end up actually going with Unity, like if I get through his stuff and Unity actually does work for what I want, I will probably just pick up his course. It's a very expensive course for me because I live in Canada and USD to CID. And this is a USD course, so it's $150 almost, right? So it's expensive.
And despite being a big change, changing from OOP to DoD, that change is actually not as intimidating as it sounds. We're going to start from the absolute basics of dots and slowly, step by step, increasing complexity. So by doing that, the learning curve will actually be quite smooth. And by the end, you will have gained an insanely powerful tool that you can use in making whatever games you want to make. Now, like I mentioned in the course page, this is not a beginner level course. So I'm assuming you're already at the intermediate level. I assume you know what is a game object, what is a transform. I assume you know your way around Unity. I assume you know what are generics, events, and singletons, and just basic C# knowledge. So I assume you are intermediate, but when it comes to the topic of dots, I'll teach everything starting from the absolute scratch. Since one of the primary goals of dots is to enable massive performance with tons of objects moving around, because that naturally one excellent genre for learning about this tool stack is making an RTS game, which is what we're going to do. This involves lots of units and lots of logic being applied to lots of objects at once. Doing an RTS game using game objects that requires quite a lot of trickery to make it performant. Whereas over here by using dots, as long as we do it properly, we're pretty much going to get awesome performance by default. In the final game, we're going to have tons of units finding tons of zombies. We're going to have multiple buildings, units finding, resource gathering, massive zombie hordes. We're going to learn how to create full field pathfinding, how to do fog of war, how to create the minmap, set up zombie building spawners, handle shooting, melee attacks, different unit types, and so on. We're going to learn how to do dots animation, learn about the various sorts of dots, like how the baking system works and what exactly how structural changes, as well as how to combine dots and game objects in various ways. So all this will be built step by step. There is no code written off screen. All the lectures also have the downloadable project files. So if you get lost at any point, you can just download the exact same project files that I'm using and continue from there. And as usual, I'm always available in the comment section to answer any questions you have. So now let's see the final game that we're going to build in this entire course. Let's see that in the next lecture. Hello and welcome, I'm your Code Monkey. Here, let's look at the final game we're going to build throughout this entire course. Alright, so we start off with a super simple main menu. This means we're going to handle all about scene loading and dots. Let's go ahead and just play. And yep, this is our game. So we have a bunch of units, we have some resources, we have a nice UI, we've got buttons, we've got a minmap, we've got special skills, so we've got all kinds of things. This is an RTS game, so naturally we can click to select and move a whole bunch of units. So I can click to draw a selection area and move them around. And there you go, there are some zombies. So as the entities get close enough to a zombie, they start attacking, they start shooting. Then zombies also have some really nice satisfying ragdolls, so as soon as they die, they fall down. They also have the health bar over there on top of the unit itself. So they walk around, they deal all kinds of damage. Then over here we can also see the fog of war in action. So we can see there's a persistent dark fog of war, so that one has been unexplored. Whereas if we do explore it and we go back, yep, now there it becomes explored. Then the game has a nice horde system, so every once in a while we get a horde, so we can move around. And of course we can also spawn some buildings. So let's place down a tower. This one takes some resources, so we can place down a bunch of towers. They also have rules, so they cannot be placed way too close to one another, so they need to be a little bit far apart. So place down a bunch of towers. Let's prepare for the horde that is coming. Let's clear off all those zombies. And here we have the first zombie horde coming. This one is pretty simple. And another nice mechanic is our special skill. So here we have the airstrike, which is triggered once we kill enough zombies. So I can click, and there you go. And after a while, a bunch of helicopters come in. They drop a bunch of bombs, and there you go. Everything drops down. So it's a really nice special skill. Then on the
Isn't Code Monkey's games and stuff actually very simple in terms of interactions? They're mostly management games. I suppose. I don't know. I've never actually played any of his games.
the buildings that we can build, naturally we can build a barrack, so that is one from where we spawn our units. Then we can spawn a whole bunch of harvesters. So this one over here, this one in light gray, this one is actually an iron harvester. Except of course we need to be able to afford the cost, so we need some gold. Up there we can see our resources, and there's another horde, so let's actually defend from it. So here we have a gold node, so I can place a gold harvester, place it next to the gold node, and there you go, the building starts doing construction. So it spawns from the bottom and starts going up. So it has a nice construction state. So it goes, and once it gets fully built, yep, the building also has a view radius, so we can see the area around it. And there's some nice visual drones to gather around and gather some resources. So we can start gathering that. We can start placing down a whole bunch more buildings. So let's place down some more gold harvesters, place them all. Then over there, let's defend from this horde. The towers themselves, they also defend, but they also can be destroyed. They also the units have the game. Give the thing step by step, starting view of all the steps we're going to take in this entire course. So let's see that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to see a quick overview of the entire course. So all the lectures and all the things we're going to learn and build step by step until the final polish game. Okay, so we're going to start off with a lecture mostly focused on the theory behind dots. So what exactly is it? What are all the components to it, like ECS, job system, and burst, and just basically getting a nice overview of the whole tool stack before we start using it. Then we're going to start the
Dots is in yeah, it's a Unity, not really played with Unity. So it is the mass entity system from Unreal effectively, except for Unreal got into this much later. So Unreal didn't release theirs until Unreal 5, and Unity started releasing theirs like 7 years ago, I think. Like when was No, this is the official release. Oh, 2018 is when they started. Wait, what? Mass is getting scrapped? Oh. Well, I imagine that that CG Project Red's thing is probably still just an entity component system at the end of the day. Yeah, but you still need the packing. Like, I don't know. I think you still need the entity component system underneath it. But yeah, like mass doesn't feel fleshed out or even well thought about. It feels like, oh, we need something, so let's slap together something, and it feels so slapped together sometimes. And it doesn't feel like they're making any progress on it. Like they've released a little, like there's a little bit of progress being made on it. Like I don't even think it's on their roadmap. Unreal Engine roadmap. Like I don't think it made they really even put this on the roadmap at all. Mass entity. Yeah, they pretty much haven't done much work on it at all since oh, here we go. So instanced actors is the last thing that they did. And we have the state tree stuff. Yeah. So yeah, it's just this and this are the two ones that are relevant. But it's just like not moving, so. Ooh, some new audio widgets. Oops. I do love me some what's this? I don't know. Yeah, I don't know. It just still feels like they're just like not really wanting to invest time in it. You're right. Nanite seems super important to them. And I'm just like, I don't I just don't care about Nanite or Lumen. Which was easier to completely remove them, to be completely honest. Time code support? Seriously? Oh, interesting. Cool. Yeah, that's true.
The section for creating and setting up our project. First, create the project and install all the packages. Then we're going to set up our Unity layout. After that, set up our Visual Studio. Then import the first batch of visual assets that we're going to use. After that, set up the post-processing and lighting. And with that done, we will have our complete setup. And in order for you to follow everything exactly the same as I have in this course, this is the part where I will tell you to download the project files to use. So this way, use the exact same project as me with everything using the exact same versions. That way, there is no confusion. Then we start actually building our game. So first, learning about dot subscene baking. What is it and how do we convert game objects into entities? Next, we're going to create our first super simple component. Component store some data. So we're going to do that and set up our unit structure. Again, all while using normal game objects in the baking system. With that done, we're then going to create our very first system. It's going to be the unit mover system, which like the name implies will move our unit. Meaning that at this point, we will have seen the basics of entities, components, and systems. Then we take that movement system and we're going to refactor it to use dots physics instead of moving the object transform. This is super easy to do thanks to the dots baking system. We're going to work with normal physics components and everything just works. Then since this is an RTS game, we're going to need the mouse roll position, so we're going to calculate that. This is also a super important lecture because it will teach us that not every system needs to be dots. We can and we will have normal model behavior scripts and dot scripts, both of them working together. Then with the mouse position, we're going to use that logic to tell the unit to move to the mouse. And then here is another super important lecture. We're going to refactor our movement code to turn it into a super fast job using the job system. We're going to see the actual numbers behind normal main thread code and super fast burst enabled multi-thread code. The difference is literally 100x. Next, we're going to handle unit selection. First, just setting up the component to select just one unit, and then we're going to be selecting multiple units. This means we're going to set up our UI and do some math to be able to draw a selection area and select multiple units. This is another great example of interacting with the dots world from a normal model behavior script. Next, we're going to handle selecting a single unit by clicking on it. This is another fun lecture because it requires us to learn about dots physics and how to do a dots recast. Then we're going to generate some move positions for our unit to go to. That way, they don't all go to the exact same spot. This is basically where we can draw our own unit formations. Next, we're going to have a very important lecture, learning how to do events in dots. This is actually really tricky because normally events require objects and delegates, so finding a data-oriented approach for events is a really interesting challenge. Then we're finally going to create some zombies to play with, create the enemies, and define what is the concept of a faction. After that, we're going to build our fine target system. So this system, coupled with the concept of factions, will work for both zombies and friendly units.
Is it me, or does he not have any animations on his characters in this? Dots can do animations,
It will work
right?
for both for finding units of the opposing faction, and this also requires us to work with dots physics to find nearby potential targets. Then we're going to implement the concept of health, create a component to store some data and systems to handle that, then create a visual bullet that we're going to fire, set up the component and system to make it move towards the target and damage. Next is another really important lecture where we're going to learn all about entity spawning. This has some interesting implications with regards to the concept of structural changes. After that, we're going to polish some things in our shoot logic, then set up a simple component and system for spawning zombies. Then we're going to make them randomly walk around. This requires us to learn how to use a random class that is burst compatible, which works in quite a different way than you might be used to. Next, setting up a visual health bar. This also requires an interesting setup to make sure that the bar is rendered using the dots renderer and is scaled correctly. Then we're going to polish up the shooting with some nice lights. So this one is a great example of how we can use dots companion game objects. After that, we're going to implement melee attacks, so our zombies will be able to approach our soldiers and damage them. Then we're going to implement a move override logic. This will let us have full control of our units even while they are trying to attack an enemy. Next is a simple lecture learning about required for update. This is how we can define a required component before a system updates, so this helps us solve issues with singletons not existing. Afterwards, we're going to do some refactoring to make our find target system always find the closest target. This is a simple change. This lecture is actually a great example of how refactoring is a perfectly normal part of the process. First, we make the find target system, and then we add some more logic onto it. Then, continuing with targets, we're going to implement the logic to lose a target. Make it so that if the target is too far, it just gets reset. Then create a simple component to override a target. This allows the player to target a specific unit, regardless of any others being closer. And for another target logic, we're going to set the target when hit. So when a zombie gets attacked, it will target the unit that attacked it. After that is another nice refactoring lecture. This one is all about performance, all about refactoring normal systems and making them into super fast bursted jobs. Like I said, this is how you should do it. First, get working with a simple system for each. Then about how to create an overview of how we're going to implement it, and then we're going to start.
Is utilities have animations in the start? Oh, his units have animations in the start? Okay.
Building off the basics, preparing everything so we can build upon it.
Oh, there we go.
Next, we're going to learn about dot blob assets. This is the main way that you can store large amounts of data in an easy-to-read structure. We're going to use blob assets to basically store all of our animation data. Then we're going to build upon it to store multiple animation data. This requires being a little bit tricky with how we set up the blob asset. After that, we're going to learn how to change animations on the fly. For example, go from idle to one animation. Then with that done, we're going to implement some events so we can play our animations when they should.
As we start talking about it, he talks about it.
We're going to implement the
I don't care, dude. I don't care.
Figure out how to optimize a bunch will be fully complete and really awesome. So as you can see, we're going to go step by step from a completely empty project until the final
There we
polished game.
go.
We're going to start from the absolute basics of dots, learning how to convert a game object into an entity with a baking system, then how to make a simple component and a system to run it, learning how to use burst and a job system for massive performance, how to use dots physics, and a bunch more. So little by little, we're going to learn more and more about dots in a nice smooth learning curve, while also building our really nice RTS mechanics. So yep, this is everything that we're going to learn in this course. In total, 17 hours split across 75 lectures. Again, remember to take your time. It really does not matter how long it takes you to go through this course. All that matters is that you're learning. So take it slow and just make sure you're understanding everything. Alright, so with all that said, let's get started. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to start with the absolute basics, learning exactly what is dots and what does it do. Okay, so before we begin building the game and writing some code, let's first cover the absolute basics of dots, just so we're all on the same page. Now, dots are
Let's just do this real quick as well. There we go.
the dots that stands for the Data-Oriented Technology Stack. This is a set of technologies that Unity built, which are based on some very specific rules, like being data-oriented, and by following those rules, it can provide you an insane amount of performance. This was a very ambitious tool set. They started working on it back in 2017, and only very recently became production ready. The benefits it can provide are definitely immense, but they do require a different way of thinking. So my goal over here in this course is to have a bunch more packages. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to begin setting up our project and installing all the packages. Okay, so let's begin setting up everything. Now, if you want to follow the course as you go along, normally you aren't supposed to follow along. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to set up our Unity layout. Okay, so here we are in our project. Let's just customize our layout. It's very important that you set up your layout in a proper way so that you have easy access to all the things you need and you know where exactly everything is. Now, you can set up the editor in any way you want, but it will probably be easier to follow this course if you're using the exact same layout as me. And like I said, since this course is meant for intermediate or advanced users, I am assuming that you know the absolute basics. So I'm assuming you already know what exactly is the inspector window, what is the project window, the hierarchy window, and so on. I'm assuming you know what is a game object, what is a component, transform, and so on. So I'm assuming you already know all of those absolute basics. Now, in terms of layout, I've been using Unity for over 10 years now. I started making my first Unity game in 2012. So let's see the Unity layout that I've developed over the years. First is the inspector over here on the right side. This way we always have a nice view of the selected object and whatever scripts it has. Then for the hierarchy, I like to grab it and place it down here on the left side. We're going to make sure that our scene is always nice and organized, so we don't really need the hierarchy to take up tons of space. Then with the project files over here right next to it, with the console also over here on the next tab. Usually I find that when making the game, I want to look at the project window, but then when playing, I mostly just look at the console. So keeping them in the exact same place but on different tabs, that makes perfect sense to me. Then over here in center, we have the scene view, and with the game tab, either over here on the exact same next tab or over onto the side. So depending on whether I want to see both of them at once, I swap it out one or the other. Okay, so the basics, this is the rough layout that I normally use. Now for a couple more options. So over here on the project files, on the top right corner over here, you see these little three dots. Over here, I like to set it as one column layout. Basically, this showcases all the project files, all of it in this nice compact list tree view. Now if you need to browse lots of visuals in your project files, then you can swap back into the other one. But for most of the time, this compact view works great. Also, since we're here, just in case you don't know, there's this nice little button over here with an eye. This basically shows the visibility of the packages. So over here, we can see we have all these packages installed. And if we click on that, basically that folder shows up as empty. Packages still exist, they're really just hidden. So just a small thing in case you want to browse the packages, untick this. But in most cases, probably leave it ticked, leave everything nice and collapsed. Okay, that's for the project window. Then over here for the console. For this one, let's also go into the three dots for some more options. The main one I like changing here is over here the log entry, set it as just one line. Basically, this makes the console nice and compact, which personally I prefer. You can see a bunch more logs without taking up quite a lot of space. Then of course, if you want to read the whole log, you can just click on it and view the whole stack trace. Then if you want, you got some more options. So show timestamp or not, using monospace font or not. You can choose whatever you want. I'm going to go with these settings. Also, extremely important is over here these three buttons. This is for the type messages that appear in the console. So the left one over here, this is info messages. Basically the regular messages. We're going to use this quite a lot. Next we've got the warnings, and then we have errors. Basically, if you want to toggle any of these, then the messages over here will not show up in the console. This is something that a lot of people find quite tricky. So if you ever come across an issue where for some reason nothing's showing up in the console, definitely make sure you check these buttons. Always make sure they are all ticked so you can see exactly every single message. Then over here on the left side for clear, I like to clear on play just so everything resets. Then for collapse, this one basically collapses messages that are exactly the same into one entry and then just shows a number. Now personally, I don't like this. I want to see every single message as it comes, even if it is duplicated. I've also seen this lead to a lot of confusion for some people. They think their code is just firing one message when it's actually firing hundreds. So to avoid any confusion, leave this untoggled. Then for error pause, yep, we do want this ticked. We want the game to automatically pause if some error occurs. If you untoggle this, you might get an error, but the game might keep playing, which might in turn lead to a bunch more errors. So always leave this toggled. And that's really it over here for the console. Then let's go over here onto the game view on the center. First over here on this tab for the free aspect, let's swap from free aspect into full HD. This is the standard aspect ratio. Technically, this will really only matter when we start working on the UI and positioning elements. But either way, I like to put it on 16:9, just as always. And then for another very important option over here, let's enable VSync. Basically, this will limit the frame rate depending on your monitor's refresh rate. This is really good to make sure that your graphics card doesn't go crazy trying to render a completely empty scene at like 1,000 frames per second. This way it will be limited. In my case, will limit it to 144 FPS. And also, if your game view is looking pixelated, then make sure you check out this slider. If you move it like this, then this looks really pixelated. So always make sure this one is all the way over to the left. Okay, that's the game view, and next to it we have the scene view. Now for this, pretty much on default should be good. Now over here, these two are extremely important. Definitely make sure you know exactly what these two mean. These basically place the handles that you see, like for example the move handle. If I select something, there you go, that move handle. If it is like this, it's placed on pivot. But if it is on center, then it's placed on the center of the object. Usually this is very confusing. So if you ever see your handles in weird places, make sure this one is on pivot. That is probably what you want to do. Then for this one, either local or global rotation. Sometimes local can be useful if you want to rotate or move something while ignoring the rotation of that particular object. But in most cases, probably leave it on local. Then over here, let's show the grid on the y-axis. There's no need for snapping. And over here, all these also look good. So let's leave it on shaded draw mode. With 2D disabled. Sound doesn't really matter for now. Let's leave all the various effects enabled by default.
Why does he talk like Chat GPT? The extended pauses for each sentence throws me off. It's just the way he chats. Yeah.
Just without the always refresh.
He's been making videos like this for longer than ChatGPT's been a thing. So it's definitely not ChatGPT. But if you're ever a little bit curious of whether or not something is like a AI based audio, if you play it at 2 times speed, it is stunningly obvious. Stunningly obvious. It is so obvious the second you put it at 2 times speed. I've like listened to things where I'm just like, that doesn't quite sound. No, I know. I realize that, Pixel, but if you're like, I've watched some videos and I'm like, this doesn't sound right, and then I speed, if you speed them up, it's just like, oh, it's chat, it's an AI voice. Yeah, AI voices actually like They really, really, really show themselves the second that you have them at anything faster than 1 time speed. Because there's a cadence, and the cadence goes away, but it can be hard to catch the awkward samey cadence if you're not speeding it up.
Let's hide heavy
weird.
objects. Then for the layer, show all of them. For the camera, everything on defaults. And
It's-
for gizmos,
it-
again,
the
everything.
AI
Okay,
voices
so
are
here's the
getting
layout that I'm
better.
going to be using throughout this course. Like I said, it will be easier to follow the course if you're using the exact same layout as me. So ideally, you should be using this. But again, all the windows are customizable. You can place them anywhere you want. So if there's something you absolutely prefer on a different place, then go ahead. You can drag windows and place them anywhere you want. And once you have a layout that you're happy with, go ahead on the top right corner and you can go ahead and save the layout. So in this, I'm going to save it as the dots RTS course. If you ever get lost, you can go ahead, you can reload default layout or go back into that one and everything reloads. Okay, great. So our layout is all perfectly set up. Now the next important thing is setting up Visual Studio. So let's continue that in the next lecture.
Yeah.
Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to set up our Visual Studio. Alright, so with the Unity layout all set up, let's make sure Visual Studio is also set up correctly. Now for here, I'm using Visual Studio Community 22. This is the free version. You can download it directly from their website. Now you don't have to use the exact same ID that I'm using here. Technically, you can use something else. Like it says here on manual, you can use whatever ID you want, as long as it supports source generation. That's really important since Dots does use quite a lot of source generation. Specifically over here, they mentioned Visual Studio 22 Plus, or rather 21 Plus. So you can use whatever you want. In my case, I'm going to be using Visual Studio 22 Community. Now let's see my setup for Visual Studio. Now I've also included the file with my Visual Studio settings along with the project files on this lecture. So just like with the project files, you don't have to go into Window, open up the package manager, and over here, let's just make sure that package is installed. So up over here, the Visual Studio editor, make sure this package is installed. And again, in your case, if you're using JetBrains Writer, then go ahead and install this package. Next,
That's a package? I didn't realize that was a thing. Good thing I didn't completely skip
inside of
this.
Unity, let's go into Edit and Preferences. Then over here on the left side, let's go into External Tools. And here, make sure you select your external script editor. In my case, I'm using Visual Studio 22. Then for these extra options, if you want to play around reading the source code, like for example, the source code for dots and so on, if you want that, then you can go ahead and take these boxes. But in our case, for this simple game, we don't really need to do that. So let's just leave them like this, and everything's working perfectly. So now if I go up here into Assets and open up the C# project, here, there you go, it does open up Visual Studio. Okay, great. Now we're here for some more settings. Again, like I mentioned, export all settings to a file that you can download. So here in my Visual Studio, I have a nice extension that adds a bit more colors to my code, which makes it easier to read and write. And for that extension, let's go up here into Extension, Manage Extensions. Then again, I'm going to search for something called Viasphora. Here, there you go, this one. Like I said here, the main things that add some rainbow braces, so a bunch of like this. And here are all braces. I think more readable. So next for some text formatting rules, let's go again into Tools, into Options, and then up here let's go into the text editor. And again, I believe here everything is pretty much default. These are the settings. Again, you can just download them and download that file. Go ahead and make a set of this course, and just yep, with that, you should have your Visual Studio set up exactly like mine. Again, this will avoid. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to import the visual assets that we're going to use in the first part of this course. Okay, so here we have our project set up. Let's import some nice visual assets. Now, the assets that we're going to use, those are the ones made by Synty Studios. They are an excellent team that makes some really gorgeous low-poly assets. Personally, I'm a huge fan of their style. I've used them in many of my tutorials and in my own game, Dinky Gardens. They have allowed me to use part of their packs in this game and distribute them to you. The license for the assets included in this course is you can use them for non-commercial use only. So if you want to use them in your own commercial projects, you can pick up the entire packs from their store. The assets that I selected are from a bunch of their simple series. It's a very blocky low-poly style, which personally I found that it looked really great for this game. I think it looks really great for an RTS game. A lot of assets are from this simple military pack. Then for a bunch of buildings, I picked them up from the simple space pack. And of course, for the zombies, they came from this simple zombies pack. Now, I really like their style, and like I said, if you want to use these assets in your own commercial projects, then go ahead and pick. I'm showing you all the setup, or drag it onto select all, and go ahead and import. And here it is, right away we have all of our assets in our project, so we can see a bunch of textures, we can see a bunch of meshes and materials and all kinds of things. With this, we can right away set up a basic scene. So first, let's actually clean this up a little bit. So instead of calling it simple scene, let's call it the game scene. Yep. Then let's right click on the hierarchy, let's create a 3D object, let's create a plane, name this our ground. Over here on transform, let's put it on 0, 0, 0, so right on the origin. And for the scale, let's make it quite a bit bigger. Let's put it on 40, so 40 on all of them. Then let's also go ahead and use a ground material. So here inside the materials folder, we have the ground desert, so let's just go ahead and apply 0, 20 characters, so 4 units, post-processing and SAO. So let's expand that one and assign that material. Yeah, there it is. And for the zombie, let's also assign this material. All right, that should do it. So some more visual things. We want to set up lighting, post-processing, and look really nice. Okay, so here we have some assets and we have our camera set up. Now let's make it look nice. We already have the project set up to use URP, so adding post-processing is actually pretty simple. It's already somewhat enabled by default. Here, this scene that was created automatically already has a global volume, and by default it already has a volume profile attached. So let's use this as a starting point, but let's also just rename it. So instead of sample scene profile, let's just give it a proper name, so the game scene profile. Okay, so now here let's set up the effects. Well, of course, keep in mind this is really just a visual thing. So if you prefer a different visual, then feel free to use whatever effects you want. It's a global volume, and by default it already has a volume profile. We're going to more visual things. We want to set up lighting, post-processing, and SAO. So let's do that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to set up post-processing and lighting to make our scene look really nice. Okay, so here we have some assets and we have our camera set up. Now let's make it look nice. We already have the project set up to use URP, so adding post-processing is actually pretty simple. It's already somewhat enabled by default. Here, the scene that was created automatically already has a global volume, and by default it already has a... Hello and welcome, I'm your CodeMonkey. In this lecture, the goal is very simple. Let's just download the project files and start the project from there. This way you have the exact same setup as me with the exact same version numbers, everything with the exact same settings, everything is exactly the same. This is going to help avoid quite a lot of... Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to start learning...
Yeah, I'm just like... Don't care. Not setting up this
Learn the basics of
project.
dots. Learn about subscenes and the various dot windows. We're going to create an empty game object and learn about the
Where are we
basic
at?
workflow that converts game
We're at
objects
almost an hour and we haven't even started actually working on this.
into dots entities. Okay, so here we have our empty project with all the packages installed, everything ready to work with dots. Now the first thing we do is create what is called a subscene. So here on the hierarchy, let's right click and let's go here create a brand new empty.
Okay, so we come down here, we close this. We want to do this, right? And then we go to assets and we create new... No, wait, we go into here and we do create. Yeah, that's fair. No, it's good to try and be up to date, right?
Subscene. Everything ready to work with dots. Now, the first thing we do is create what is called a subscene. So here on the hierarchy, let's right click and let's go here, create a brand new.
Oh, it's in the hierarchy. Yeah, in the hierarchy. Oh, new subscene. There it is. Empty subscene. Scenes.
Empty subscene. Let's call it something like entities subscene. And yep, there it is.
Pedestrian subscene.
So basically, this is how you can mix game objects and entities. Objects outside of the subscene, like all these game objects over here, all these are regular game objects. They will not be converted into entities. They have nothing to do with dots or ECS or anything like that. Whereas objects that we place inside of the subscene, those will automatically be converted into entities. So let's actually see that in action. Let's right-click directly on top of the subscene so that whatever we create ends up inside of it. And over here, let's create a brand new game object, and let's just make it a simple 3D cube. And if there it is, we have a cube directly inside of the subscene. And over here, we do see it. Over here on the scene view, we do see our game object cube.
Cool. Wait, where is this? 0, 0, 0. Let's move this. There we go. Wait, can I just... I guess I can just do 0. And then we want the environment here to be 0, 0, 0. And this environment here needs to be 0, 0, 0. Then we look at this and we want 0, 0, 0. But then we want to also bring it down maybe. -1. Oops. -2. Oh, wait. 0, but then we want to take this, and this goes -1. How far down is that? Okay, that should be enough. Then if we take all of this and we bring them up, there we go. Now we can take a look at this here, and this will be in the right spot. Beautiful. Okay. So now if we go into here, he said we're just going to add a cube to it. Yeah. Hey, look, there's my cube. cube. Why is it way the fuck over there? Oh no, it's way the fuck over here. Interesting. It's not relative to the owner. Huh. It's a parent location. It's a parent location. I think that other cube is, yeah, I placed that and that's a different cube altogether. Some of these cubes I was placing for other reasons. There we go. Where's this cube? Oh, there we go. It's kind of annoying that it doesn't place it in the scene. It's all good. It's all good.
View. In the game view, the camera is indeed rendering that cube, and over here on the inspector, we do see the regular components. So we have a mesh filter with mesh assigned to it, we have the mesh renderer, the box method, and so on. All of these are normal game object components, and of course, if we hit on play, yep, everything still runs, everything is still the same. There's our cube, again, just like a game object. We created using the
Let's go run down the cube. If I'm not mistaken, it's over here somewhere. It's somewhere around over here. There it is. So this is 0, 0, 0. The cube is zeroed. But it's not, for some reason, the cube is not being set relative to the scene, the subscene. Which irritates the fuck out of me. Zero the subscene? Yeah, but then do I just move the cube? Because I thought that I just like move the, it's confusing. Oh well. Finished. Because children are relative to their parents' position normally, apparently, but not in a subscene. Give me a couple here. I'm gonna go grab some food. I'll be right back. Nope, it's a game object thing. Kind of poopy. Oh well. I'm just gonna be microwaving some food. Got some leftovers from when the girlfriend made congee the other day. So I will still be right back. We're still microwaving, so. So this is what my girlfriend brought home. What the fuck? You had a girl? Yeah. I'm dating Rem Toto's cousin. Rem and I are like family. The 22. I have no idea what this is supposed to be. It's a bolt action though, but it's a solid piece of plastic. It's a Sorry, it's a what? Does it? Oh, it's a Remington Model 700. Yeah. Ask next time you chat with Rem, just be like, is Pseudo dating your cousin? And he'll say yes. It's not like particularly like Rem and I talk about it all the time. For anybody wondering, here's the lunch. Not that anybody's probably wondering. Let me move this out of the way. And I'll move this. So I got myself a ginger beer for the drinks. A bowl of chicken. My bowl of congee. And some homemade chili oil. You know Tiny Nookie? Maybe? Yes. No, it's a bowl of congee. I think Gaz rated him, right? I think I'm following him. I thought I was following him. I also know niche. Okay, so we're gonna add in some chili oil. This is homemade chili oil from my girlfriend. I really like her chili oil. She doesn't use it because it's too spicy for her. Is it like rice? Yeah, it's a rice porridge. It's what congee is. With chicken. It's an Asian comfort food. Is congee the porridge the same as congee signs? Congee is something that is involved in most Asian cultures or Southeast Asian cultures, right? That are very rice focused. But congee, the characters are not. So congee shows up in Vietnam. Vietnam does not use congee characters. They use Roman characters. Specifically, they use French characters. But I think congee originated in China. I could be wrong now, because a lot of those countries have influence from China. Like, even if it's like a really distant, like really distant one, a lot of them do, because like, you know. There, nice and spicy. Delicious. I think that's about a good amount of spice. Probably could have done with a bit more, but whatever. I'll be right back. What, do you not like spicy, or do you think it should have been more spicy?
All right, so
Am I on the wrong one? There we go. Yeah, but it's rice porridge. It's different. You're supposed to eat rice porridge with meat. It is somewhat. It depends. It's so like for Vietnamese. It's like something you would eat when you're sick. Kanji. Right? So you would eat this when you're sick. And then if but as you can see, like if you look at kanji, right? Like it always has stuff in it and it's always savory stuff. You can really load it up with whatever you want. So it gives you a nice base, right? That's easy on the stomach, easy to digest and eat, right? So which is perfect for when you're really sick. So it's not going to upset your stomach or anything like that. And then you can load it up with whatever flavors are going to work for you and a protein that's not going to upset your stomach. Yeah, it's just going to be easier to do this. It's pretty watery. It's like a little bit watery. It's more, it's about the same consistency. You can have it about the same consistency as you would have like oat porridge, right? But it's just a porridge. It's rice instead of oats. And they traditionally eat it with proteins. Is this something you've never had? I've never had corn porridge. Interesting. I'd try corn porridge. Why not?
Exact same method, and everything looks exactly the same. However, if we select the cube and over here and look on the inspector, if we go down here, we see this little thing said the entity baking preview. Baking is essentially a DOTS term. It is a process by which game objects and their game object components are converted into entities and their entity components. So it's kind of like making a cake. You take some raw dough, you bake it, and you end up with a cake. So DOTS is kind of like that. Here we have the normal the mesh assigned to it. We have the mesh renderer, the box slider, and so on. All of these are normal game object components. And of course, if we hit on play, yep, everything still runs, everything is still the same. There's our cube, again, just like a game object. We created using the exact same method, and everything looks exactly the same. However, if we select the cube and over here and look on the inspector, if we go down here, we see this little thing said the entity baking preview. Baking is essentially a DOTS term. It is a process by which game objects and their game object components are converted into entities and their entity components. So it's kind of like making a cake. You take some raw dough, you bake it, and you end up with a cake. So DOTS is kind of like that. Here we have the normal game object with normal game object components. Those components are then baked, and during the baking process, we then end up with an entity that has all these DOTS components. So down here, we are just seeing all the types of the components that we're going to see, and by clicking, we can actually see some more data in those components, and we can also see all this data all at once. So on the inspector, on the top right corner, we have this little circle here. Here we can basically modify the mode of our inspector. So authoring, this is what we're seeing right now. So it shows us all the authoring game object components, so all the normal ones that you're used to seeing. But then if we click on it and we swap it into runtime mode, yep, now here we can see all the entity components and all of their data. For example, you can see how instead of having a regular transform component, instead of that, we have a local transform. This is a dot component. Also, by the way, if you don't see it, that is probably because you went over here on the authoring and you remove this box slider. If you do that, and now we go back into runtime, yep, now it does not have the local transform component. Basically, dots is pretty smart. This baking process is pretty intelligent. It will only bake components as they are needed. And basically without any physics, just an empty game object, this one does not need the local transform component, so it does not get it added. Whereas if we leave that on, so let's go here into authoring, and let's add the box slider back in. If we go back there, yep, now we do see the local transform component. And again, during the baking process, all the data is automatically converted. So if we go back into authoring, and let's put this on position 5, 3, and 2, and now if we go inside the runtime component, here there we go, now it does have the exact same position. Again, the process of baking, the goal of it is to take the game object components and all of their data and convert them into their equivalent dots components. Also note how the components do not match one by one. So for example, over here on the authoring components, on the normal game object components, we've got transform, mesh filter, mesh render, and box.
You know any Japanese manga facts purchase? Per chance? I barely know any Japanese, to be honest. Give my, like, Rum and my girlfriend are both Vietnamese. Heritage-wise. Rem's Australian though, and my girlfriend's Canadian. As far as I know, yeah. Wait, how did you not know that he was Australian? He has an Australian accent. Oh, you watched him like twice? Okay. This also explains why you didn't realize you didn't know about the Rem's cousin. Although Chris didn't know for a long time either. I made a comment about like because like I was laying in bed watching Chris before I passed out. And my girlfriend was still getting ready for bed. And I was just like, I'm just waiting for Rem's cousin to to come to bed so I can go to sleep. And he was like, what the fuck? Hmm. If Rem's there, it's not my game, it's our game. Because Rem and I are working on this together, and Aku's in on this game too. Yeah. So Aku made the truck. Aku made this truck, and Rem's making the characters. And then Aku's probably going to finish up the rest of the vehicles. Oh, I forgot to eat the rest of my chicken. Yeah, effectively.
Box either. So we have 4 game object components, whereas if we go inside runtime to see dots components, we can see we have quite a lot more of those. This is actually a very important concept in dots. It's how your authoring data can be different from your runtime data. Later on, when we create our own custom authoring components, we will be able to have, for example, one game object component turned into multiple dots components. This can be really useful to simplify some things on the authoring side, doing that so that it's really easy to build things, but then convert it into some specific components to make it super fast on the runtime side. So this is the baking process. This is a really important part to know about dots. It's how game object components are directly converted into dots components. This system is what makes dots actually surprisingly easy to use. For the most part, you can actually keep using regular game object components, and then everything gets converted into dots components. So on that note, talking about the conversion.
There we go, I'm back. That's the weirdest desktop background I've ever seen. Well, you know, somebody's got to do it.
Let's learn a little bit about what baking is actually doing. Basically, as it takes all of this game object data, as it converts that data into dots data, as it does that, that process is essentially taking all the game object data and converting it into binary dots data. So if we look on the hierarchy here, if we look inside the subscene, we can see how it has this little checkbox here. And actually, if we click to select the subscene, if we look in the inspector,
Since most of the weird ones, you see. Wait, what? You saw Code Monkey's background? I didn't think he ever showed it. I'll show you mine. It changes all the time. It annoys the fuck out of me, but I don't see it enough that I care.
we can see how this subscene is actually just a special game object with a special subscene component. So even though the hierarchy looks like something real special, in reality it's really just a game object. But anyway, so here we have this little checkbox, and this one is basically for opening or closing the subscene. So right now it is open, meaning we can inspect all the objects inside the subscene. We can go here, we can move it, we can modify any of this data, and then we can close it. Or before we do, let's just hit on save. We have a little asterisk saying we have unsaved changes, so Control S just to save it. And now if we click on this, there we go, the subscene is now closed, and now we can no longer inspect the objects that are inside.
It's, let's see. I think if I go to personalize, it's just like, I thought I asked for this, but I've also just done like blank colors before. Oh wait, no, that's an accent color. That's not what I wanted. Wait, personalize. There we go. Yeah, here we go. Background. Solid color. Yeah, that's more of the background that I want.
Inside of the subscene. The object still exists. We can still see it over here on scene view and on game view. So the object still exists inside of the subscene, but it is now no longer open for editing. So what happened here is that object with those game object
The birds are one of like the Windows automated ones where it's like, oh, click to see the place.
components, all of that was baked directly into binary data, and that is the exact same thing that is being loaded directly in here. This is exactly why one of the huge benefits of dots is actually world streaming, meaning how you can have, for example, a huge open world, and you can have it split into various parts, and then you can dynamically load and unload each of those parts. That's usually how open world games are usually made, and the way that dots has a huge benefit in that aspect is because dots works with binary data, and binary data is insanely fast to load. So the baking process here, converting this game object cube into actual dots binary data, that process essentially means that the game does some really heavy processing right now during edit time, but then it is insanely fast to load and unload during runtime. So like I said, it's really excellent for creating huge open worlds. You can split a giant world into multiple subscenes, and then very easily dynamically load and unload those scenes as the player moves throughout that world. So right now with the subscene closed, right now we cannot edit our objects with its authoring data. So here in the hierarchy it does not even show up. However, dots also has some entity-specific windows. So let's go here up top into the window menu. Let's go down here into entities, and we can open up the entities hierarchy window. So here it is. This one is very much like the normal hierarchy, except instead of showing game objects, it shows entities. It also has multiple modes like the inspector, and it has a toggle to see various worlds at the same time. Now sometimes this window gets a little bit bugged, sometimes it doesn't update. If that's the case, you can just reselect the world and everything should update. But anyways, the main point is that if you look in the game object hierarchy, with the subscene being unloaded, being closed, this way we cannot inspect the object. However, inside of the entities hierarchy, over here, even though the subscene is closed, we can indeed inspect the entities that are inside of that subscene. Now we still cannot modify it because again, it was baked into binary data. But if we hit on play, if we start playing the game, again, here's the bug. Here, let's switch it into runtime mode. And again, here's the bug, it's not updating, so let's select the default world. And there we go, now it does update. And now we can select, for example, this subscene. And again, another strange bug, so on the inspector, let's go back into authoring mode and go into runtime mode. And in the inspector, let's just go into runtime mode. And yep, here we do see the dots components. So the entity is live, and since the game is running, now we can indeed modify this data, and yep, everything works correctly. Whereas on the main hierarchy over here, we still see just the normal game objects. Whereas if we stop playing, and now let's open up this subscene for editing, and yep, we can now see the cube, and we can now start playing. And yep, now we do see the cube still selected there. And while the subscene is open, we can actually modify it. So if we go in the inspector, we swap it back into authoring mode, and we modify this one, and yep, modifying this over here on the game object inspector, modifying this one.
I think I know why subscenes don't have a parent transform, like they're not a relative transform. And I think it's because that way, if you dump a bunch of stuff into them, they keep their location. And the math isn't fucked up if you do. So that kind of makes sense to me.
Does automatically trigger a sort of bake and actually modifies the entity that's currently running. Now, when making the final build of your game, you want everything to be running as fast as possible. So in that case, you want to close the subscenes, or if you're working with tons of them, you probably only want to open one of them. But while building our game, we're mostly going to leave it open just so we can easily edit things. And this entities hierarchy window is also very useful at some points. So let's leave it open. Let's just put it right next to the hierarchy, just like this, so we can access both of them easily. Also note one thing, how when we hit on playing over here on the entities hierarchy, we can see all of these entities were created. Some of these are default entities that Unity creates automatically to set up the entire game world. So some of these are going to be related to rendering, others for various systems and so on. Every system also has a corresponding entity, but don't worry about that for now. We're going to learn about systems in a little bit. And let's see also one very interesting thing. So if we go inside the hierarchy, so the normal game object hierarchy, and let's right click on the subscene, let's create an object inside the subscene. In this case, let's create a completely empty game object. So there it is, a game object. It's completely empty. The only thing it has is just the default transform component, just because this one we cannot remove. So this is a completely empty game object. So we can see it over here inside of our subscene. But if we go inside the entities hierarchy, and
Holy shit, Don. Thanks for the raid. How was the stream? How's your project going? I just had lunch. You even know the raider? Yeah, I know Don. I think I'm going to pick it back up soon. Up on stream. Starting next week. Oh yeah, you were doing Python, right? I put off Twitch to Sprout for too long now. Yeah, I know what you mean.
And nope, it is not in there. Even if we refresh this, nope, it does not show up. And same thing if we select this game object and on the inspector, if we swap from authoring mode where it does show, if we go into runtime mode, nope, it does not show. It says this is an invalid entity. This is another very important thing. Basically, the baking process will indeed convert all the game objects inside.
All right, see you, Don. Have a good one. Parody bit. Thank you for the follow. Much appreciated. Welcome to the stream.
Inside the subscene into a dots entity, it will do that, but only if there's anything to actually convert. Now in this case, this game object is completely empty, and when something is completely empty, the baking system is smart enough to not waste any time converting that object. So just be aware if you make something completely empty and it is not a child or a parent of any other object, if it has no components, nothing. If so, then something completely empty will not automatically be converted into an entity until you finally add some components, which does trigger the baking process. As long as you have a kind of bakeable component, this game object will indeed be converted into an entity. And by default, like we saw, dots already works with a bunch of the built-in components. So if you set up your game objects with some of these basic components, if so, they won't automatically be converted into dots components, like we saw over here with the rendering. The rendering did convert automatically. We can look here in the runtime components. We can see it as a chunk world render bounds. We can see it as the material mesh info and a bunch more rendering components. Same thing for the physics. We can see it as the physics world index, a collider, and so on. Let's see how dots physics already works by default. So let's first of all get rid of both these. Let's right-click, create a new game object, and this time let's make it a sphere. Let's lift it up a little bit, and over there let's go into the operating component, and let's make it a little bit bigger. Okay, there you go. We have our sphere right there. Down here on the baking preview, we can already see all the various physics components that will be baked. So we've got the physics collider and so on. Now let's add a rigid body. Again, a normal rigid body component. So a perfectly standard game object component. Let's add the rigid body, and now let's make another object. So inside the subscene, let's create a new 3D object. This time let's make it a plane. Let's lift it up by a little bit, and let's make it slightly tilted just so the sphere falls down a little bit. Okay, that's really it. So we created both a sphere and a plane, and importantly, we created both those using normal game object components, the normal game object process. So far we didn't do anything that was specific to dots. And just with this, if now we hit on plane, and right away we can see it does work. We can see that sphere fell down and is now rolling along exactly according to physics. Right, awesome. So just like this, our dots entities already have physics and everything working. So this is really how awesome the baking system is. We just work with normal game object components like we're used to, and then they are automatically converted into entities with dots components, and everything works with dots physics. Also, right now you might have noticed something interesting. So if we hit on play, we can see here in the game view, the sphere did fall down and is now rolling down. But over here on the scene view, if we look, we can see on the scene view, the sphere is actually still up here. And if I try to move this object, you can see the actual dot entity, that one kind of teleports up there. This is a little bit strange, but it's actually very much intentional. Like I said, the baking process happens just once. You edit things, and then game object get baked into binary data for all the entities. And over here on scene view, basically we are seeing the edit time pre-bake world. And this is actually saying that we can change. So let's stop playing. Let's go into edit, go into preferences. Then over here on the left side, let's go into entities. And here we have the setting for the scene view mode. Here we can change. Do we want to see on the scene view? Do we want to see the operating data or the runtime data? Now, for the most part, I find it a little bit confusing to see operating data. I think runtime data makes more sense in most cases. So I usually set it on this one. Let's click. And now if we hit on play, and if now we do see both in scene view.
Never known you managed to get anything. I did never know. I did never know how you managed to get anything at this speed. What do you mean? Some people are still too slow at this speed. There's actually a number of Twitch YouTubers that are entirely too slow at this speed.
View and game view, everything looks exactly the same. All right, so here we learn how dots baking works. This is a really crucial part of dots. It's how we can keep working with game objects for building our game, but then automatically convert them into super fast entities for our runtime. So now that we know how baking works, it's time to create our custom component. So let's do that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to set up our unit and learn how to create a custom dots component along with its authoring component. Okay, so in the previous lecture, we already learned how the baking process works. So here we have a sphere and a plane. We set it up using normal game object components, which are then converted into dots components. So if I hit on play, then you have all of these regular game object components converted into dots components, and using dots physics, everything falls down. Great. Now that we've tested that, let's get rid of these two objects, and let's set up our normal unit object. And for this, I'm going to build a unit like I normally do, meaning normally I like to have a parent game object with all the logic components, and then child game objects for other individual things. Like for example, the visual mesh, the visual selected, any kind of thing like that, those will be child objects, but the parent one will be an empty game object with just logic. So let's go ahead, right click again directly on the subscenes. We're trying to make a game object that will eventually be converted into an entity. Let's construct a brand new.
For all the new people, the link to this video is in the description. This is a 7-hour video, but he goes through everything. I've been skipping through it a bit.
Empty game object. Let's name this just a unit. And if this is going to be the parent game object, this is where we're going to place all the logic components. And now inside it, let's make another empty game object. So inside, let's create another empty one. Call this one the mesh. Let's make sure that it's on 0, 0, 0, scale of 1, 1, 1. Okay, great. Now let's add the usual visuals. So the mesh filter and the mesh render component. And for the mesh, let's select over here the soldier aim mesh. See, there it is, the soldier aim mesh. And for the material, let's make sure to assign one over here inside materials characters, the soldier material like this.
Wait, what? Oh, I wanted that. Sweet. Wait, I need to change something. I think it took me out of dark mode. There we go. Oh, dope. Okay, that's totally something that I want. Okay, so if I create, okay, so I want to delete this. And I want to create an empty object, right? And then he had this as a unit. That's fine, yeah. Here we're going to say a pedestrian. And then he adds a mesh, which is another empty object, and he calls this mesh, right? And then on that, he gives it a mesh, right?
Mesh. Let's make sure that it's on 0, 0, 0, scale of 1, 1, 1. Okay, great. Now let's add the usual visuals. So the mesh filter and the mesh render component. And for the
Okay, so add component mesh filter and mesh render. Oh, that's fucking amazing. Okay. And then he adds his mesh.
mesh, let's select over here the soldier aim mesh. See, there it is, the soldier aim.
And then in my case, I'm going to take. Can I edit these so they've got the. Oh, I can. Yeah, here. No, that's a prefab. I don't want that. Okay, so we go to the mesh and then we take the FBX and we add it to here. Oh, wait, it's because it's not a mesh, right? Wait. It. Does an FBX doesn't count as a mesh? Oh, okay. I see. I see what's going on. Back from ads. So if you want top bar of Unity to be dark mode too, there's a free asset on the asset store. I'll worry about that later. So so a mesh can't take a skeletal mesh, right? So he did this. Right? And I was like, "Oh, cool. Let me." No. I thought Unity had a dark mode. Oh. Well then. Never mind. If I'm not mistaken, assets like Unity assets are just like actual FBX files, right? So like this is an actual FBX file. I wouldn't need to like export it. I'd be able to access it directly, right? So if I did file. Mm. It can? Why won't it let me then? It won't let me drop a in the mesh filter. It won't let me drop in a mesh. Uh, um yeah, that's what I was thinking. But still like okay, so if I just save this as an FBX, right? Hmm. Okay. I think this is missing all of the bones. Yeah, there's no bones. Okay. I think there's no bones. I'm like 80% sure here. No, she still has bones. Oh well. It's inside? Oh. Oh, I see. Would it be this one? No. Is it this one? It's that one. What's going on with this? Is this just like her hair or something like that? What does this even look like? Oh, that's definitely not it. Why is her all mesh not working? Does this one's all mesh work? See, mesh filter is inside that FBX itself. Currently, you're dragging. You click the arrow. Sorry. It's missing a material, but try dragging the FBX. Like just this. Is it because she's made up of more than one material? Oh, sup, Danny. So, huh. So this doesn't work the way that I want it to. Oh, that was a crack. So how would I bring in the FBX then? If I wanted to do it in this. Weird. Whatever. We can move along. We can do this entirely with cubes. So I'm just gonna probably just do that. Wait, where's my game? Here. Yeah, we'll just drop her for now and do this part with cubes. There we go, cube.
A mesh. And for the material, let's make sure to assign the one over here inside materials characters, the soldier material, like this. And if there it is, there's our nice mesh visual. So we have our soldier unit. Now, I like the structure of having an empty game object and then a bit more versatile as we want to add more things onto the unit. Like one common example is sometimes you have visual meshes that are not exactly the same size that you want. And if you take this approach and you can easily scale, you can modify, put it on some kind of offset. You can apply that on the child object and leave the parent object on the exact same position with scale of 111. So that's one of the many benefits of this method. Let's go ahead and reset this to everything on 0 and 111. And like I said, later on, we're going to create more objects, more child objects. Those are going to be for the select visual, the fog of war shape, the minimap icon, and so on. All of those are going to be child objects. So this is how I like to set up my objects. One parent game object with all the logic, then visuals and other parts in child objects. But just to be clear, this is not a requirement. Like we saw, we can create just a regular sphere and use everything directly on just one game object. So I just want to clarify what is a personal preference versus what is a requirement. So anyways, here we have our game object set up, and it's already correctly being converted into an entity. If we hit on play and we see on the entity's hierarchy, yep, here we have the mesh entity. Again, the parent is not being converted because right now it's actually empty. Like I mentioned.
Okay, let's. Can I just move all of this? So I guess we don't need to move the. Yeah, here we go. Okay, I'm gonna put them here, and I just want to. This is gonna be a bunch of them just walking around there. To do a batch draw command was submitted with an invalid batch mesh ID. Okay, interesting. Clear, that's fine. Let's create a material real quick here. Material. And then we just want a kind of gray material. That works. And then we just add it there. That's not what I said to do. I said to put it there.
Have some kind of component that will be baked in order for the entity to actually bake. So now is a great time to see how do we create our own custom dots components. Now this is actually going to be pretty simple. So over here on the project files, first of all, let's create a nice folder to organize all of our scripts. So right click on the assets, let's create a new folder called scripts. And inside, let's right click on the scripts folder, go under create. And now here we've got tons of menus. So let's go over here inside the entity submenu. In this case, we want to create a component. So let's choose an I component data script. Let's name it move speed like this. Yep, that's it.
Okay. What did he call it? Yeah, no, we're gonna do create folder D. He said an
Tons of menus. So let's go over here inside the entity submenu. In this case, we want to create a component. So let's choose an I component data script.
okay, I component data script.
Let's name it move speed like this.
Danny, how's your game coming? Does it move data? Oh no, move speed. God damn it. Someday over the rainbow. Move speed. There we go. 2 years later. Beautiful. Okay.
Yep, that's it. Let's open it. And here it is. Here we have a component. It is super simple, as you can see. This is all it takes to define a component. You just need to implement I component data. This is an interface, but this has no methods you need to implement. It basically just works kind of like a tag to identify this type as being a component. By the way, this interface itself, as you can see, exists inside the unity.entities namespace. So make sure you add the using statement up top. And the other very crucial part is this has to be a struct. This is extremely
Is this not going to already be that? Yeah, okay, it's already set up.
important, and it's why dots is as fast as it is. Remember what we learned in the what is dots lecture? How the insane performance benefits we get from dots comes from being basically very clever about memory usage. Now, normally in C# code, you work with a lot with classes. For example, model behaviors, those are classes. And the main difference between class and structs is how classes are reference types, whereas structs are value types. Or another way that Unity likes to refer to those two types is as either managed or unmanaged, meaning their memory is going to be either managed or unmanaged by the C# runtime. So classes are managed components, or reference types, whereas structs are unmanaged components, or value types. Other examples of value types are the basic types like int, float, bool, and so on. And reference types are classes and pretty much any kind of object. So for example, arrays are also reference types, and strings are also reference types. Now the difference is, for example, when we define a class and then we construct an object of that class, when we do that, like I said, classes are reference types, meaning this variable over here, this one is not storing the class object directly, it is not storing the actual class data. Instead, this variable really just has a pointer, and then that pointer points to a certain position in memory, and this memory itself, this memory position, this is what actually contains the class data. Whereas if we define something as a struct, we construct a brand new struct, and by doing that, that struct, that variable is actually holding the actual struct data. Meaning there are no pointers, there are no references to anything. The struct data is stored directly here. The power of dots is really all about how it handles memory, how it packs memory in some super tight chunks, and doing so then allows the code to run super fast between all the components within this chunk. It is super fast because it is accessing contiguous memory locations, meaning one all after the other. Whereas with game objects, those are regular objects. So for those, the CPU basically has to jump from all kinds of positions in memory in order to find whatever kind of data it needs. So it needs to go forwards, backwards, and so on, constantly jumping in memory, and this is actually quite costly. This leads to a lot of things called cache misses, which is where the CPU basically loads a ton of positions in memory when it requests one position, which is how entire cache. Both with reference type. Now, in general, changing something from a class into a struct literally just means swapping out the keyword. Instead of class, we write struct, and yep, that's it. That defines it as a struct. And in doing so, naturally, we change it from reference type onto a value type. However, that change does have some very important implications. The main one being in terms of working at something as a copy versus as a reference. So, for example, if we have a class, my class, and we construct an instance of that class, and then a second one, and we make it equal to the first one, when doing so, both these variables, my class A and my class B, both of these are storing the exact same position in memory. Because again, these are classes, meaning they are just storing the positions in memory. They are not actually storing any data itself. And in doing this, basically, they are both just storing the exact same position in memory, and the actual data, they are both pointing to the exact same data.
This, you're copying the data.
Now, what that means is if we went to go through myClassV and modify some field inside of it, it would also modify the value inside myClassV, because again, both variables, both are referencing the exact same underlying data. Whereas if we do that with structs, structs are value types and not reference types. So if we do the same thing, so construct a brand new struct and then assign a second one onto that one, if we do this, instead of having two variables that both point to the exact same object, instead of that, we have two copies of the underlying data. So if we were to modify some field inside myStruct B, it would not automatically modify anything inside myStruct A, because again, both are separate pieces of data. They are not pointing to the exact same thing. When working with structs and when we assign a struct, what we are doing is we are creating a copy. We are not storing the same reference to the original data in memory. We create a copy of the data. So when we modify something inside myStruct B, we are modifying just that copy, and we are not touching the original data at all. Now, this is really very crucial to understand. You must fully internalize this difference, really understand how structs work as copies and not references. You need to know this so that you don't get confused when at some point you write some code and have no idea why it isn't changing. It is probably because you're working with a copy of the data and not the original data itself.
The question I've got now is, can C# make pointers out of a struct? I'm assuming the answer is
For example, later on in this course, when we write some systems, we are going to see how if you get some component and you just modify it, it won't actually update the value in the component attached to the end, because again, the component will be a struct and structs receive copies. So modifying that copy will not modify the original data. But we'll cover that when we get to systems. For now, I hope you understood the difference between structs and classes, the difference between value types and reference types, or the difference between managed and unmanaged. All of that is extremely important to dots. So now we can continue working with our component. All we need to define a component is, again, make it a struct and make it implement iComponent data. That's it. This is now a dots component. And now inside this, we can place whatever that we want to store inside of this component. For example, for some kind of MoveSpeed component, let's just store a float for the MoveSpeed value. So we literally do just this. So public float and call it value. That's it. Also, by the way, if you're a regular on my channel, you might have.
okay. So yeah. What did he have? Value. Okay.
Heard me talk a lot about clean code principles, and the main one is how you should never make everything public. Usually I tell you to always make it private and then expose it with some kind of field, like float get value, and over here you would return the value. This gives you a lot more control as to how your fields are accessed, so that's how I usually recommend you do it. However, ECS is a very different thing. That oriented design is very different from object-oriented programming. For example, components in ECS, these are not meant to have any functions at all. These are just meant to store data, just fields, just data. So you are really not supposed to have any kind of functions inside of your component. Technically, you can do it, the compiler won't stop you, but you really should not put any functions inside of your components. The general idea of ECS is you have entities, which are really just IDs, then you have components, and those should only store data and nothing else, and then you have systems, which are the things that actually do some work, do some logic on that data. So since subcomponents are really just meant to be simple data containers, if so, then it makes sense for them to just have their data directly exposed, so making it public. This makes sense in Dots world, in ECS world. When working with normal game objects, I definitely encourage you to keep those same clean code principles in mind. When working with mono behaviors, always minimize access as much as possible. But over here in the world of Dots, in the world of ECS, go ahead and expose your fields by making them directly public. Okay, so here we have defined our component. The component is called MoveSpeed, and inside we just have a value field of a float. So let's just go ahead.
I'm gonna tell you all something about the difference between the way Python deals with public and the way that other languages deal with public. And I kind of almost agree with Python on this. And I know that like it's still considered bad, but like I kind of get it too. So the Python approach is everything is public. And there is a mechanism in which it is suggested that you do not access something directly. You access it through a different manner. And that is by putting an underscore as the first value, right? So in Python, if I effectively want to make something private, right, I would do, it'd be like public float, and then it would be my value, right? And this would be private, but not really private, right? So it wouldn't actually be private. You could still access it, but your IDE will probably complain to you because you shouldn't be accessing. So, but the take on why, right? Like, one sec. The take on why is you are an adult if you want to shoot yourself in the foot by accessing something that the creator of the library told you not to. That is up to you. You're an adult. Shoot yourself in the foot if you want. Yeah, C# takes after C and C++ and Java. Yeah. See, like, so the whole idea of like, oh, you gotta protect your private data, it never really meshed with me. Like I get it, and I've done it. I've made things I still make things private when I'm in like C++ and C and stuff like that, like languages that utilize those concepts, I still do it. And I do it in Python as well. It's like, please don't access this, right? By putting an underscore. But at the end of the day, right, the idea of everything being public gives you the flexibility that if you need to access it for some god awful reason, and this does happen from time to time, right? Where it's like, oh, I need to access this, but I can't because it's private. Then that can't be hidden away from you in Python, right? You're not prevented from doing the interesting thing, because if we prevent you from shooting yourself in the foot, we prevent you from doing interesting things. But yeah, it's like, you're an adult. Be an adult. Don't do stupid things. That's like actually what the Python creator said when he was quizzed about it. He was just like, you're an adult. Don't be an idiot.
And save this and wait for Unity to compile. However, now if we inspect our entity, if over here we click on unit and look at the runtime component, and nope, it still does not exist. Unity does not exist because again, it's simply empty, so this entity would not have any component. Naturally, it did not magically get our newly created component added. So the question is, how do we add a component onto an entity? So one way is through code. We can just call a function to add a component onto an entity. We're going to do that later on many times. But once again, we can really just use the baking process. So like we already saw for the default components, how those get used as normal game object components and then that get converted, get baked into DOTS components. That is all the baking logic, and we can also implement baking logic for our own custom components. That way we can keep building our objects using normal game object components and then have them be baked into DOTS components. So the way we do that is with
It's bad practice. Like in C, C++, C Sharp, all of the languages like that, it's just bad practice. So you just don't do it.
the model behavior component. So on the scripts, let's right click, go ahead and create. Let's create a new model behavior script. And now for the name, a nice convention is to name it just like the component, so move speed, and then simply append the word authoring onto it. So move speed authoring. So yep, just like this. Here is the normal model behavior component, the standard.
Okay, so then it has the authoring. Can I actually just do it from here? I know I can do it from here in move speed. Was it authoring? Interesting. It gave me it gave me a namespace. I didn't actually want a namespace.
Thing that I'm sure you're very used to. Now here we can add whatever fields we want to have in our model behavior component. In this case, since in our move speed component, in this one we expose some kind of value, let's do the exact same thing. So over here on this one, let's also expose a public float value.
Wait.
Behavior component. In this, so yep, just like this. Here is the normal model behavior component, the standard thing that I'm sure you're very used to. Now here we can add whatever fields we want to have in our model behavior component. In this case, since in our move speed component,
What was mine called? This is why is this not move speed? Wait, is it supposed to be space there? Yeah, okay.
in this one we expose some kind of value. Let's do the exact same thing. So over here on this one, let's also expose a public float value. However, again, like we mentioned, this is not a requirement. Like we saw in the previous lecture, you can have one authoring component that gets baked into multiple different dots components. So your components do not have to have the exact same fields. It all depends on what you're trying to do. In this case, we do want to easily define the move speed value in the authoring component and use the exact same thing in the dots component. So up here on the model behavior, let's find the same public float value. Okay, let's go ahead and save this. Wait for Unity to compile. Then let's select our unit. And in the inspector, let's put it back into authoring mode. And let's just drag our move speed authoring component. So just the same as any authoring component. However, just like this, we still don't have any baking. We can see down here the empty baking preview. That one is still empty.
Wait. Fuck. That one. We'll build. Succeeded with warnings. Is this going to be a common thing? Okay, there we go. It was probably just warning me. I heard there's a lot of boilerplate with yeah, probably. One second, I
Load
gotta see what
volume.
he
Okay,
did here.
let's go ahead and save this. Wait for Unity to compile. Then let's select our unit. And in the inspector, let's put it back into authoring mode. And let's
Okay, so we select our here. Is it the mesh? It's just like, let me just put this into authoring mode. So there's the unit. The unit has a transform. Does my unit have a transform? It does have a transform. But mine doesn't have the...
just drag our move speed authoring component. So just the same as any authoring component. However, then let's select our unit. And in the inspector,
Oh.
let's put it back into authoring mode. And let's just drag our move speed authoring component. So just the same as any authoring component.
Oh, I see. I see. I see. Okay. And this would be on the pedestrian that we added. There we go.
However, just like this, we still don't have any baking. We can see down here the empty baking preview. That one is still empty. We have created a dot component and we have created a model behavior authoring component, but those two are still completely separate things. There is no connection. The way we define that connection, or rather the way that we define the baking logic, is with a baking class. So here inside of our model behavior, inside let's define a nested class. Let's make a public class. Now we can name it whatever we want. I like to name it just Baker. And then the very important part is let's extend the Baker class. And this one right here, the one inside the Unity dot.
Okay. Public class Baker.
In these namespace, so make sure you add that one on top. And this one takes in generics, and the generic type should be what type we want to bake, which in this case we want to bake this type, the move speed authoring. So let's go ahead and put it like this. So yep, here we have a Baker class which extends this Baker class. Now the important thing is over here on the type that you use inside the Baker generic, it is the authoring class. It is not the dots component. It is not this one. It is the authoring component. Okay, great. And also, like I said, for the name, you can call it whatever you want. You can use whatever word you want here. It doesn't really matter. It does not have to be called Baker, but I think that makes quite a bit of sense. And also, technically, it does not have to be a nested class. We can put it down here and everything works the same. But again, I think it makes sense since it is related directly to this component. It makes sense to place it directly in here. So with this, we have defined our Baker, and we can see we have an error. Basically, we need to implement this bake method. So let's do that. And actually, we can use Visual Studio to help us. We can place the cursor on top of the error. Then use the quick actions to implement the abstract class. And there you go, it writes the code automatically. If you're not using Visual Studio or you don't have these kind of quick actions, you can just manually write this function. So we've got a public override void, we're going to override the bake function, and this one is going to take in a parameter of the exact same type as our authoring component. Okay, so now we need to implement this function. Now this one is going to run during the baking process, and this function we do have an access to our authoring object. Meaning this is where it can grab this component, which in itself has all the data that we want to expose, and we can convert this into our regular dots component. And in order to add our dots component, we use the add component function, and this one takes in an entity parameter. So the way we get our baked entity is with another function. So let's call get entity. This one takes in a parameter for our transform usage flags. Now this is a really nice optimization thing. It has to do with whether we want the baked entity to have a transform component or not. Like we saw a while ago, if we were to remove the box value component, then the baked entity would not have a local transform component. That's an optimization thing. So here for the transform usage flags, we have a bunch of options. For example, if our entity never moves and does not have any kind of concept of a worm position, like for example, let's say if it's an inventory container, if so, then we can just select none and it will not have any dots transform components. Or if the entity does have a worm position but will never move, like for example, static visual objects placed in the world, for that one we can use renderable. In doing so, it will have a matrix component in order to be able to render, but will not have a local transform since again, it will never move. So if you want maximum performance, definitely choose the most restrictive usage flags you have here. But in most cases, you probably want your objects to be able to move. So in this case, let's go ahead and choose dynamic. This means this entity.
Okay, so this would be get entity, and then here we would do transform, dynamic.
Entity, which in this case is going to be our unit. This one will have all the transform components, which means it can have a worm position, it can move, rotate, scale, and so on. So yeah, this function will now return our baked entity. And now
Okay, and then this does return the entity.
using that entity, we can then add some components. And so in this case, we want to add our move speed components over here, just new move speed, and let's add this component. And yeah, that's it. We are adding it, but we also want to assign the value there. So instead of adding it like this, instead of constructing using the parameterless constructor, instead let's just open and close the curly braces, and then in here we can set the value. So this is the value inside of move speed. We can grab the value from the authoring component. So let's go inside the authoring component and grab the same value. Okay, so yep.
Okay. Authoring dot value. Oh, that's nice and easy.
That's brilliant. So basically, this function is going to run during the bake process. In doing so, it will create an entity that has the dots transform components, and then it will add a component onto that entity. And the component we're going to add is our custom move speed component, and that component will be initialized with the value field on exactly the same as we have in our authoring value field. So that's it. Let's save. Just wait for it to compile. And now here in the editor, let's make sure the inspector is on authoring mode. And over here, let's set the value speed again on the authoring component, so the model behavior component. Let's set it to some number like, let's say 56. And yep, now let's go.
Okay, so then if I go back to here, oh wait, let me build this. How do I get rid of this? What's going on here? Unity 6 dots. View packages? Unity. How I want to kill you. Fucking why is this happening all of a sudden? There was a conflict between oh. Yeah, pick the newer one anyways. Wait, does it I think does it want 4.0.000 or whatever? Is that what it's wanting or is That's more than a little bit annoying. I wonder if like I restart if it will fix it. Anyways, we'll just for now let's just do this.
Let's go swap the inspector into runtime mode. And sometimes this bug happens, so this entity does exist, but for some reason this
Please unlock inspector. The entity does not exist anymore. Please unlock inspector if Oh, right. Move speed 56. Beautiful.
this bug happens. If it happens, very simple, just deselect and reselect the unit. And there you go, now it does show. And if we scroll down here, yep, we do see it does have our custom dots move speed component. And yep, the value does match exactly the one that we set in the model behavior component. All right, awesome. So basically we created a brand new component type called move speed. It implements icomponent data, meaning this is a dots component. Then we also created an authoring component. This is a normal model behavior component. We attached that normal model behavior component onto our normal game object. Then we wrote the bake logic in order to convert the authoring component into a dots component. And yep, the final result is that our baked entity does have our custom dots component with exactly the data that we want. So yep, everything worked perfectly. Now that everything is working, let's just do one more thing. So right now we have two scripts, the move speed and the move speed authoring. This works as you can see, but in order to not end up with literally hundreds of files in our project with a ton of duplication, in order to not have that, we can also just merge both these into just one script. To do that, let's go ahead and grab our dots components. So let me cut this one, go onto the
Yeah, that's true. That's true, and it also better. Although I think I would have gone the other way. Like, I think that this would have made more sense because, like, we're doing move speed at the end of the day. But I guess because, like, we're not directly accessing move speed, we would want this. And then here we can delete this. And then build.
The authoring component, and let's paste it right down here. Now let's go ahead and save both these files in Unity, wait for it to compile, and let's delete the move speed. Okay, I'll like this, let's make sure everything still works. And yep, the unit does still have the dots component, and on the authoring, yep, does have the authoring component. So this works, but now we have just one file, and this one file contains both the authoring component, the background logic, and the dots component. So this makes it quite a bit easier to work with. Everything is just in one place, very easy to work with. Also, let me make just one quick note here. In order to make this work, then the name of the file here, the file name itself, this one has to be named just like the model behavior component. If you were to name this file just move speed, it will not work. In order to use this authoring component as a regular actual model behavior component, in order to use that and be able to attach to some kind of unit, then the file name does need to match whatever class is inside of it. So in order to use this method of putting everything in just one file, just make sure
Hey, I was right not to change things without knowing why.
the file name itself does match the authoring component. So yep, down here we have our dots component, then we have the authoring component, and inside we have the nested baker class, which bakes our authoring component onto our dots component. This is the standard format that I'll be following throughout this course when making components. Dots component, authoring component, baker class, and so on. Also, let's keep our project nice and organized. We're going to end up with tons of scripts. That's one thing about dots. You do end up with quite a lot more files than with object-oriented programming. So in order to make sure this does not become very messy, let's make things nice and organized. So inside the scripts folder, let's right-click, let's create a brand new folder, and call it authoring, and this is going to be where we place all of our authoring components. Let's just verify again that everything's working. Let's hit on play mode. Let's select the unit. Yep, it does have the component with whatever value we want. Then go into runtime, and yep, it does have the move speed component, the dots component.
Okie dokie.
Okay, great. All right, so by now we have already learned how to create entities by placing a game object inside a subscene and letting the baking process do its thing. We also learned how to create a custom dots component and how to create the authoring component that bakes game object data into dots data. So we've already learned both the E and C and ECS, the entities and components. Now what's left is the S for systems, so let's learn about that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn how to write our first system to make our unit move. This requires us to learn how to do entity queries. We're going to first just move a transform and then later on do it using physics. Okay, so far we have our move speed component. It stores a field for the actual value that we're going to move. We have implemented the baking system and attached the authoring component to the game object, so the final entity is going to be baked with our component and with the correct value. But so far it's not doing anything. If I hit on play, then obviously nothing happens. So going back to how ECS works, entities are just IDs, components store data, and systems are what the logic on that data. So let's make a system to move our unit. So here in project files, again, let's keep things nice and organized. So inside the scripts folder, let's make another subfolder. This is going to be for our systems. And now inside the systems folder, right click, let's go to create, let's go down under entities, and now let's make this one an I system. For
Create folder systems. You said systems, right? Yeah. Create. No, entities. System script.
for name, let's go with unit mover system. And let's open.
Sure, unit mover system. Works. Did Unity just crash? Mm. One sec. What was it? It was unit mover system. I can't rename this inside of Unity. It's impossible because the second I go to rename it, it starts loading. I love it. It's perfect. How can I turn off autocompile? Please tell me that it's going to actually change the name. Oh, that's fine. Wait. Probably not. I might have skipped through that. Do you remember where that is? What was it? It was. Did you disable the auto reload like Monkey said? Yeah, I totally did that. Hmm. I totally did that. I don't know what you're talking about. Let me look at. That was totally something that I did. How do I trigger a reload now? In Control R? Oh, okay. Just like this. Okay.
By the way, personally, as a rule, I like to append system to the name of my systems. You don't have to. It's not a requirement. I just find it helpful to easily be able to identify what.
Uh-huh. Mm. Cool. That wasn't what I wanted at all. But okay. There we go. Okay, this is not that important. It's not that important right this moment.
What types are systems? Okay.
He has an on create, on update. I have those. Okay, sweet.
Okay, so here we have our default system. Now, once again, Dots has some very specific requirements. So first of all, we need to implement iSystem. This interface has a bunch of functions. This one also needs to be marked as a struct, not a class. And importantly, this one needs to be marked as partial. Now, if you're not familiar with the partial keyword, basically this is how you can define a type in multiple files. So you can define part of the class or the struct in one file, and then another file define another part. The way Dots works is very much based on source generation, meaning you write some code, but then the system auto-generates a ton more code in the background to make everything work. That's how, despite Dots actually being so complex, it is not that difficult to use. It is because a lot of the tricky code is actually auto-generated. But here the important thing is these requirements: implement iSystem, make it struct, and make it partial. Also, let me make one quick mention. ECS actually has two different system types. We have our iSystem, but then there's also system base. Now, the difference between these two is system base meant for managed systems, and iSystem is meant for unmanaged. Or put another way, iSystem is meant for structs, and system base is a class. Now, in general, you should prefer iSystem as much as possible, basically because it will be burst compatible and much faster. In this course, I actually don't think we're ever going to be using system base, just because whenever we want to do something that uses lots of managed data, we're actually just going to make it using a normal model behavior. So in general, don't really worry too much about system base, just know that it exists, but for the most part, we're going to be using iSystem. Okay, so here we have our system, and as you can see, we have our three functions by default: on create, on update, and on destroy. So their names are pretty self-explanatory. On create is going to run just once when the system is created. Then on update, this one is going to run on every single update, pretty much like a regular model behavior update. And finally on destroy, this one is going to run when the system is destroyed. Now in terms of lifecycle for systems, by default, systems will automatically be created and destroyed, so you don't actually need to worry about manually doing this. As soon as we play the game, the automatic bootstrapper will handle all that. It will automatically create all the systems and handle all that logic. So we don't have to manually initialize it in any way. We don't need to add it to any entity, any object. Just by existing, just by implementing the iSystem, it will automatically be registered with the automatic bootstrap. And these functions are also optional. So for example, to keep things simple, let's actually delete the onCreate and the onDestroy, since we're actually not going to be needing these right now. Right now, all we want is the basic onUpdate. Also, you might notice the burst compile attribute over here. I'm going to talk about burst in a little more detail in a future lecture when we work on the job system. But basically, by adding this attribute over here, by doing this, we are enabling burst compilation directly on this function, meaning it's going to use burst, which can make it super fast. Again, this becomes very important later on, and I'm going to cover it in a few lectures, but for now, just leave it on just like this. Now, the goal with this system, our goal is to move our unit. So if we go back to the theory behind Dots, the reason why it is so fast is because of memory management. How it packs memory read tightly together for all the components. That way makes it super simple to cycle through thousands of components. And the way we're going to run our system logic is with a query, meaning we define all of the components that we want to run that query, and then the code will automatically cycle through all the entities that match all of those components. Here in the code, the way we define a query is pretty simple. We just use system API.query. This one takes in generics, and the generic parameters over here is going to be where we define all the component types that we want to query for. So in this case, we want to move our units. So to move them, we're going to need the transform. So the dots transform, which is actually called local transform, and this one exists inside the unity.transforms. And just with this,
give me 1 sec. A friend sent me a message I need to respond to. Uh,
we should be able to move them. So this is our query, and this function over here, this one returns an IEnumerable, meaning the way we cycle through all the entities that match this query is by putting this code inside a for each. So let's do a for each, and for the parameter, it is going to be of the type of the components that we're grabbing. So local transform in our query. And yeah, just like this. Now any code that we write inside of here, all of this is going to run for every single entity that matches this query. However, it's not actually like this. This code will not actually run properly. Once again, it's due to how structs work. They are value types, meaning they work as copies. So if we just use this code and we modified something inside this local transform variable, if we did, we would only be modifying the local copy and not the original data in memory. So the unit wouldn't really move. So because of that, over here in our query, we never write just the component type directly. Instead, we have a helper class that essentially kind of transforms the struct into some kind of reference type. So the type is called refRW, and this one takes in a generic for the actual type that we want to cycle through. So you have to put refRW in there in the query and also over here on the iterator, just like this. So ref really just means it's going to act as a reference, even though the underlying component this one is a struct, by using this.
just gonna go like this real quick. Okay, so on create, we're gonna do. Oh, sorry, this is on update. Okay, he's saying ref RW, which is reference read write, local transform, right? Local transform in. To do this is not correct. System API dot query. And then we give this a ref RW, and that is a local transform, and then we delete that. And this, yeah, it does come after. Okay. That looks like it should be a lambda.
In this one, we are essentially turning that struct into a reference. So as we modify things inside of this variable, we're actually going to modify the actual data. And then RW, that really just stands for read write, meaning we can read this component or we can write to it. And the other alternative is we have refRO. This one stands for read only, meaning with this one, we can only read from this, we cannot write to it. So now you might be asking, why would you ever limit yourself to read only if you can read and write? And the answer is this will actually become super important later on when we work with the job system, meaning when we have code that runs in parallel on multiple threads. I'll explain more when we get there, but the general idea is you can only write to something from a single thread, whereas you can read that.
Yeah, I'm not super advanced in Unity. I know just enough to get in trouble. Hey,
Concurrently from multiple threads.
you know a whole lot more than I do.
So for example, if we have 100 entities and we're running some job that reads data on all those entities, then we can have, for example, 10 threads all reading data at the exact same time. Whereas if we are using a refRW for read and write, if so, in that case, then all those entities could only be processed in a single thread because you cannot have multiple threads write to the same data at the same time. So in general, you should only request a level of access that you absolutely need. Basically, the more refROs you have, the better. The more refROs you have, the more parallelized your code will be. So if you only need to read something, definitely make it a refRO. But if you need to read and write, then go ahead and make it refRW. In this case, we're trying to make the unit move, meaning we're actually going to need to write a brand new position. So because of that, let's go ahead and use refRW. Okay, so yep, here we have our nice system with our query. And like I said, the code inside this for each, this will run for every single entity in our world that has a local transform component. And just quickly, let me make one more note on multithreading. Right now, this code is not multithread at all. This for each will just run on the main thread, no matter how many entities we have. So if we have 1,000 entities, then this for each will run through all of those 1,000 entities on the main thread one by one. Making something an iSystem and writing a for each, that by itself does not make it multithread by default. We're only going to make this code multithreaded when we implement jobs in a few lectures. So I just want to very quickly point that out. Okay, so here we have our for each. Now, like I said, this will cycle through all the entities that have a local transform component. And now inside of here, we can do whatever we want to this local transform. So as a quick test, let's just move everything to the right. So let's access the local transform. And now inside we have two nice properties. We have the value RO and the value RW. Again, same thing, read only or read write. In this case, we want to write to the position. So let's grab the RW and we're going to write onto the position. So let's modify this field. Let's put the position equals, and it wants to move right. So let's grab the current position. So local transform. Right now we just want to read. So let's grab the value RO to grab the current position. And now we want to move around to the right. So let's just add a new float3 onto it. And by the way, float3, this is a special type that is part of the unity.mathematics library. So let's go up here at using unity.mathematics. And over here we can find a new float3. This mathematics library is what I mentioned.
Okie dokie.
a while ago on how it's super fast and specifically designed for dots and bursts. So this float over here, this one is basically a vector 3, meaning inside we have floats for x, y, and z. So really just like a vector 3. So in order to move it on to the right, for this, let's construct a brand new float. Let's put 1 on the x to move right, 0 on the y, and 0 on the z. Yep, so we add this onto our position and we save the brand new position. So just like this will move.
Interesting. Okay, so local transform. Dot value read write dot position equals local local transform dot rw position 1 and 0.
Move to the right by 1 unit. Except, as I'm sure you know, when moving anything, you want the movement to be frame rate independent. So over here, let's make sure to multiply by time dot delta time. However, again, dots also has a special time dot delta time. We should not use this default one, this one for the standard Unity engine. We want the one that exists in the dots world, not the game object world. So instead of time dot delta time, we go through the system API, go through this class, access time, and finally delta time. So yep, just like this.
System API? Was it, wait. Yeah, okay. Time system API dot time dot delta time. I think that's what he said. Yeah, okay.
This. Okay, so here our code is done. So we have a for each doing a query on everything that has a local transform, and this code inside of here is going to run on every single entity that has a local transform component. It's going to grab that one and set it to basically the same thing, moving right by 1 unit. Okay, so let's go ahead and save and let's test. So hit on play. Any right away does work. There's the unit.
Yeah. Sweet. Okay, so we're gonna build this. I think I did something wrong.
Constantly move is going to grab that one and set it to a query to basically the same thing, moving right by 1 unit. Okay, so let's go ahead and save and let's test. So hit on play. Any right away does work. There's the unit constantly moving right. All right, awesome. Except it's actually not entirely awesome. So this is working. Our unit is.
Wait. Did he attach this somewhere and I missed that?
This rug, some very specific. Nice and organized. So inside the source folder, let's make another subfolder. This is going to be for our systems. And now inside the systems folder, right click, let's go to create, let's go down under entities. And now let's make this one an iSystem. For name, let's call it unit mover system. And let's open. By the way, personally, as a rule, I like to append system to the name of my systems. You don't have to, it's not a requirement. I just find it helpful to easily be able to identify what types are systems.
Wait, so were all systems picked up as soon as you run?
Okay, so here we have our default system. Now, once again, Dots has some very specific requirements. So first of all, we need to implement iSystem. This interface has a bunch of functions. This one also needs to be marked as a struct, part of the class, or the but here's the important thing. But then there's also system base. Now, whenever we want to do something that uses lots of managed data, the system is created. Then on update, this one is going to run on every single update, automatically all that logic, automatic bootstrap. And these functions are also optional. So for example, to keep things simple, let's say burst compilation directly on this all the components. That way, and this function over here, this one returns an INumerable. So query is going to be where we define all the component types that we want to query for. So in this case, just with this code inside like this, we modified something. We never in a generic this variable where we have, if you can, we'll explain more entities and for reading rest level of FRO entities we have. Not make it like I said, this one is the right to the positions. So have floats you want. You should same thing. It's construct only by 1 unit. Okay, awesome. So this is working. Our unit is moved. Hit on play. Any right away does work. The local transform component is going to grab that one and set it to basically the same thing, moving right by 1 unit. Okay, so let's go ahead and save and let's test. So hit on play. Any right away does work. There's the unit constantly moving right. All right, awesome. Except it's actually not entirely awesome. So this is working. Our unit is moving, but it's actually not just our unit. As that's over here on the hierarchy, let's go inside the subscene and let's construct a brand new, let's say cube. Let's create a cube and let's put it over there. Okay, so we have our unit and we have a cube. And now if we hit on play, and you look at that, both the unit and the cube, both of them are moving right. And not only that.
Yeah, but mine's not moving. Is it because it doesn't? No, it has a transform though. It has a local transform. Is that the wrong kind of transform?
but actually the child mesh object, that one is also moving right. That is why the unit seems to be moving at double the speed of that one. So basically everything is moving right. Now this is actually a key point about dots. It's how systems do not care what a certain entity represents. The system does not care, does not know that this is a unit and this is a cube. It does not know any of that. If an entity has components that match the query, then the system will run logic.
Maybe I'm missing a thing here.
The time. So let's go ahead and hit on play in order to see these in action. So let's hit on play. And now
How do I bring up that systems? Structural change. Where's his showing up?
now if we find, yep, here is our unit mover system, and
My unit mover system's not there. Mine's not unit mover system, it's pedestrian. Yeah, it's not there.
and over here under entity count, we can see 3, meaning our system is being applied to 3 entities. So that's the cube, that's the parent game object, that's the parent entity, and the child entity with visual mesh. So naturally, this isn't what we want. We want to just apply the movement onto the unit. So over here, this should be saying 1. This system's window is sometimes useful, so let's leave it open. Let's just put it over here next to the console. Okay, great. So now let's figure out how to make our movement apply just to the entity that we want. In this case, that's actually going to be super simple. We can just add another component to our query that only exists on the unit. So we can just use the move speed component that we already created. This one only exists on the unit and only on the unit parent
Yeah,
object.
but-
So that one should perfectly target just the unit. Over here in the code,
But how do I get the system on? I think I missed that. How are we attaching the system? Or how is the system getting picked up? Unity 6 dots system. What was it? It was system iSystems. Is it because I wasn't able to attach something? Is that what the problem
let's add some more components over here into our query. And the way we do is very simple. Just add a comment and then another type. In this case, we want the move speed component. Again, importantly, it's a move speed, not the move speed authoring. Nope. Over here, we're working the dot swirl, so we want the dots component. And again, we need to find either.
Oh, wait. I did say local transform. Okay. Oh, wait. Is local transform... No, it's capitalized. Transform local to world. Oh, I don't have a local transform. No, I do have a local transform. It's right here. Is this maybe it? Yeah, it's these null references. Oops. You can click on the... Yeah, but I wonder if this is because it's static? No, it's not static, right? This Unity local transform. Null reference exception. Object reference not set to an instance of an object. I wonder if it's because I don't have these like on create and or because I do have these, or is it because I need to recompile? I found a solution. Oh, is that what it is? Oh, okay. Let me turn an auto refresh. Here. So if auto refresh is disabled, I just have to build and it will take care of that.
The ref RW or ref RL. In this case, we only want to
Okay, we want move speed. Oh wait.
read the speed from it, so let's use ref RO just for reading. So we We add it over here, and then also need to add it over here on the first parameters. And when we have more than one, we need to put this inside parentheses. So let's open parentheses over here, close them over there, then do a comma, and add the move speed component. Also for readability, I like to add some new lines, so add new line for every single component, then new line over here on the end, and then on the query components, and yeah, just like this, it is nice and readable. So we are doing a query with local transform and move speed, and importantly is this is an AND operation, meaning our query over here is going to be looking for entities that have both of these components. They need to have a local transform and a move speed component in order to run this code. But at the same time, it is not an exact match, meaning it can have more components than just these two. It just needs to have at least both of these. Also, after the query, after we open and close the parentheses, afterwards we can add a bunch more options. We can type with, and we can see all kinds of things. For example, we can use with none in order to specify this should only run on entities that do not have the following components. We can use with disable. This will make it include enableable components that are disabled, and so on. As you can see, we have tons of options. We're going to use these a bunch later on to make some more complex queries. But for now, let's keep it simple. We just want these two components, local transform and move speed. Since our unit is the only thing that has both these, and this should only run on the unit. Also, one quick note in terms of syntax. So you can write code like this. This is personally what I prefer, to be very explicit with exactly every single type. However, if you prefer, you can also just use var. So just type in var before that parentheses, and then over here do not define the type, just define names, just like this. And yep, this is valid code, this is valid syntax, this works exactly the same. Some people prefer this. Unity actually uses var a lot in their own documentation. Now, personally, I am not a fan of var. I like my code to be as explicit as possible, so there are no questions. I want to be very, very clear on what type my variables are. But again, that's really just a personal preference kind of thing. So if you do like var, then you can definitely write your code just like this. But I won't be sticking with my preferred method of being more explicit by defining all the types exactly. Okay, so far so good. So we have our query, and the query is going to run on entities that have both of these components. Now let's just use the move speed value directly in our logic. So instead of moving right by 1 unit, instead of that, let's read the value. So let's go inside the move speed, go inside the value RO because we only want to read it, and let's grab the value field inside of it. So yep, just like this. Let's go ahead and save.
Ah, that's beautiful. So if we do move speed dot value dot value.
And back here in Unity, let's modify the operating component and make it move at a speed of maybe 5. Okay. Now let's hit on plain C. Hey, there it is. Now our system is only applying to that unit. It is not applying to the cube. It is not applying to the shell mesh and anything. No, it is only running exactly on the thing that we want. So it is only running on the entity that has both a local transform and a
Sup. Yeah, I'm trying dots.
a move speed component. By the way, we can also edit this value in real time.
I got tired of dealing with the experimentalness of maths entity in Unreal, so I'm trying out Unity with dots to see if it will work.
So over here,
I'm
I can click and
fairly
modify, and yep,
positive
it does
the
work.
answer
And also
is
for the other
yes.
inspector, so let's go in runtime mode. So here is all the components, move speed, and I can also play with this, and yep, all the changes work. Now this is another example of dots data-oriented design in action. We can very easily modify the data, and then by doing that, when the systems run logic on this data, it will then have a different behavior. All right, great. So here our unit does move towards the target. We've achieved movement by directly moving the transform, but to make the game feel a little bit more interesting, we're actually going to want to use physics in order to move this unit. So let's have that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn how to move our unit using physics. This is going to be quite easy actually, thanks to how Unity handles the built-in physics components by default. Okay, so here's what we have so far. The unit is constantly moving, so it has a component for the move speed, it has a system called the unit mover system, and it is moving the unit, so that's it, very simple. Except right now it is only moving by moving the transform directly. We want the unit to be able to interact with other objects, so let's make it using physics. But before we implement physics, let's just add one tiny thing. So here right now the unit is moving, but no, it's a bit odd as it's facing forward and moving left. So let's make it rotate towards the move direction. So here we are in our unit mover system. Okay, we have the local transform, our move speed component. Okay, great. So in order to rotate towards that direction, first of all, let's actually calculate the move direction vector. So we have a float for a move direction vector. Actually, this is a float 3, which again is pretty much the equivalent of a vector 3. It's just in the special mathematics library. So that one, first of all, requires the target position. So let's actually define it, as opposed to over here we're just moving right, or actually just moving towards the move speed. So let's define a float 3 for the target position. This target position will eventually be an actual proper position, like for example the mouse position or whatever position we tell the student to go to. But for now, again, let's just make it move to the right. So target position, just go into local transform onto the value RO, just for reading. Let's write the position and add a new float 3, and just go to the right by 10 units. Okay, so this is our target position and calling direction, some super simple math. So just target minus the current position, so that's the local transform dot value RO for reading, and let's write the current position. So this calculates our move direction vector. Except again, as I'm sure you know when it comes to vector math, over here this vector will not be normalized, so let's make sure to normalize it to set the magnitude to just 1. When working with the normal vector 3, usually you can just call dot normalize, but over here this one does not have that. So normalizing a vector in the new mathematics library. For that one, you assign the vector, go inside the math class. Again, this one inside unity.mathematics. Inside this one, there is a normalize function. So this one takes any parameter, so we pass in our move direction, and it returns the move direction but normalized. Okay, so yep, so with this we have our move direction, and then let's just use it over here. So instead of recalculating the direction as well, let's just set the position, and let's do position plus equals, let's add on to the position. Let's move towards the move direction multiplied by the move speed. Let's grab the value RO for reading, and let's grab the move speed value, and then finally the time dot of time. Okay, so yep, just like this, we should be doing the exact same thing. So we're really just moving right. Let's just quickly verify. In order to actually make it move right, let's make sure that the move speed component does have a positive value. Otherwise, if it has a negative speed, then naturally it's going to move to the left side. So let's select our entity inside our subscene, and let's go into our operating component over here. Just make sure it has something like 3. Okay, let's test. And there it is, unit moving right. Okay, great. Now let's add the rotation. So adding the rotation when we have a move direction, this is actually surprisingly simple. On the local transform that we've been using, on there we have the position, but then we also have a rotation. We have a rotation as well as a bunch of functions to rotate by a certain amount. In this case, we want to set the rotation to something. Now in this case, this rotation field, this one is a quaternion. And again, note how it's quaternion written like this. It's on lowercase, not uppercase. This is the mathematics quaternion. So to get a quaternion for this move direction, it's actually surprisingly simple. We can go inside the quaternion class, and then we can use the function local rotation. This one takes a forward rotation, so let's pass in our movement direction, and then an up vector. So here we can just do new float 3 0 1 0. So this is our move vector, or we can actually use a constant, and the constant is going to be the math dot up, and this is actually a function. This one returns the exact same thing, 0 1 0, and yep, like this, it should work.
Okie dokie. This all makes so much sense. And the dot stuff is actually better than the mass entity stuff so far. Local transform dot read write position, read only position, new float 3, 10 0 0. Then float 3 direction. I was actually going to do that. I was gonna be like, fuck that. This is move direction. There's no point in making that an extra variable there. Value read write dot rotation Turnian look at rotation, and this would be move direction math dot up. I don't know if I would want to do that, but it's hard to say because what's this return? A float 3. I wonder, can I do this? No, okay. That was worth a shot. This would actually be worth saving if we're going to access it twice. What's this return? Value RW. Yes, var value RW or transform value RW equals location transform dot value RW, right? Okay. What do you mean it's never used? It's used right there. Interesting. Oh, yeah, because these are, oh, right. That makes sense. These aren't they're not references, they're hard-coded values. Or they're sorry, they're not pointers, they're actual values. So you'd be recreating them. That makes sense. I completely forgot about that. Yeah.
Okay, so with this, let's do a quick test. But also one thing, definitely make sure that you have the child object. Definitely make sure this one is exactly like this. Everything on 0. It should be on position 0, 0, 0, rotation 0, 0, 0. If you do it like this, it should point in the right direction. But if you apply some kind of rotation here, then it won't point.
There is. It's called Go. I think Go has pointers. Wait, beef language it is. What is your favorite language? Everybody out there that is a programmer, what is your favorite language?
Point exactly. So make sure all these are on 0 and let's run play. And if this works, look at that. There's our unit moving right and facing right. All right.
Don was here earlier and he likes my least favorite language.
Awesome. Okay, so now we have achieved our movement by just moving the transform, but to make the game a little bit more fun, we want to use physics. We want our characters to be able to interact with other physics objects. So let's do exactly that. As usual, let's set up our unit over here with normal components. So let's select the parent game object. And this one over here, let's give the unit a shape. So let's give it a regular capsule collider. Then let's set up the settings. We can see over here on the scene view. So let's make it a little bit higher. So with a height of 2, for the radius 0.5, yep, that looks good. And let's just lift it up a little bit so it doesn't touch the floor. Let's say 1.1. Okay, yep, so there.
Let's see. "50-50 C sharp C++. Interesting.
There's our unit collider. And again, just like this, just by we want our characters. If you do it like this, it should point in the right direction. But if you apply up, and this is actually a function. This one returns the exact same thing. 0, 1, 0, and yep, like this, it should work. Okay, so with this, let's do a quick test. But also one thing, definitely make sure that you have the child object. Definitely make sure this one is exactly like this, everything on 0. It should be on position 0, 0, 0, rotation 0, 0, 0. If you do it like this, it should point in the right direction, but if you apply some kind of rotation here, then it won't point exactly. So make sure all these are on 0, and let's run play. And if this works, look at that, there's our unit moving right and facing right. All right, awesome. Okay, so now we want our characters to be able to interact with other physics objects. So let's do exactly that. As usual, let's set up our unit over here with normal components. So let's select the parent game object. And this one over here, let's give the unit a shape. So let's give it a regular capsule collider. Then let's set up the settings. We can see over here on the scene view. So let's make it a little bit higher. So with a height of 2, for the radius 0.5, yep, that looks good. And let's just lift it up a little bit so it doesn't touch the floor. Let's say 1.1. Okay, yep, so there's our unit collider. And again, just like this, just by attaching a capsule collider, just this will automatically convert into .physics. We can already see down here, yep, the unity.physics.physics collider, this one will be added. So with this, we have a collider, and then
Okay. So wait. If I go back into here, I could delete this. Right? Where did I add that? There's the move. Okay. So what I can do is I can take these two, I can delete them. I can take this pedestrian, and I can add this pedestrian to this. Damn it. I'll be right back. Okay, I'm back. Well, it was worth a shot. Wish I had a thing that did the thing.
Then for actually using physics, we also need a rigid body, so let's add that one, a rigid body. And again, just by adding, it adds a bunch of big components down here. Then for the rigid body settings, over here for interpolate, we want it to be nice and smooth, so let's make it interpolate. Then we don't want.
Okay, so was he putting it on the? Which one was he putting it on? He's putting it on the unit itself. Man, I need I need a mesh. That's just a mesh. Wait, so wait, which one did I do? I did this one, right? This pedestrian right here, which is this one. Okay. And then the issue is that her thing is not compatible with this. Unlit textures that are not SRP batch compatible. SRB batch compatible. Wait, no. SRP batch compat. God damn it. Before that one. A mesh renderer is not deforming meshes. Okay. Anything without bones. Yeah, that's what I thought. But I don't need a mesh renderer. But I do need to change my material to something that's compatible. One more serious note, do you need any custom nodes or is something or something non-standard? Maybe strange keywords or combinations or anything that might help to find the issue. Also, is it using URP or HDR? Okay, so material property is found in a Okay, so if I go to her go to materials. We go to free time. We click on this. So it doesn't like unlit, right? What if I do standard? No. Okay, what if I do... So we can't... Wait, is that the one that I've got it at? Oh, no, I don't. Okay, so this would be textures. Okay, so if I go... How do I open up a new one of these? Can I open up a second project? Unity, open second project window.
Go up to Window, then go to General, then click on Inspector to spawn an inspector. Next, you're going to want to right-click on the inspector text here, and go to Add tab, and then click on Project. And we've now opened another project window.
It's beautiful. How do I turn... No, okay, so if I go to here... Okay, here we go. That is 10. Have I started writing in this book? Oh yeah, I did. I think this black one's the one that I've been using. That was a different thing. The green one. Okay. Now I need a pen. Where did I put my pen? Do you have any pens that have ink? Yeah, this one. Okay, this one's fine. Okay, so we want underscore 10 is the body. Okay, so then if I go the universal pipeline and I go unlit here, right? And then we take this and move it to here. That should work, right? I think it did. I think it worked. Then we go here. And that is this one. 3, right? Yeah. So eyes. Interesting that it's not 2. It is 3, okay. Then we do universal, unlit, and then we move 3 in. There we go, and then we go to oh, I'm doing this on the wrong one. God damn it. Go to this. And we go to this. And then we do universal pipeline, unlit. And then we move that into there. Oh, there we go. Sweet. I'm making progress. Free time. Eyes. Jump to here. We do unlit. Or not unlit. Universal pipeline. Unlit. There. Sweet. Go back to here. That one. We click there. Sweet. It went to 2. Do universal unlit. And bam. Six. Four. That's not it. Wait, what? No, it was 7. Transparent. There we go. Free time. This one is 9. Where is it? Universal rendering. 9. And this is transparent. There's a lock button on the project window. Like this one? Oh, that's beautiful. Thank you. 16. The white's quite nice though. You can lock a lot of windows in the inspector. That's actually really good to know. I appreciate that because I would have not have known that. I did not know that. Unlit. It was 13, right? Fuck. Yeah, it was 13. Universal pipeline unlit 13. $15. There. And then we've got one more. This one is, which one was this? 14. I think it worked. Shader, universal. Yeah. Mm. Is it perfect? Absolutely not. There's this error thingy that I don't know what to fix for, but that's fine because I don't care. If it's imperfect, if it has errors in it, it doesn't matter. The thing is that a warning is not the same as an error. I don't entirely agree with that. If you know why it's yellow and it's not going to bite you in the ass, you can let it go. And then we add the component of 45. And we hit play. Yeah. Look at that. She's moving. Stop running away from me. I will catch you, you bitch. I will catch you and kill you. I'ma run you over. Hiya. I kind of wonder why I didn't hit her. How come I didn't run into her? It was probably that. Wait. Does she have physics yet? She doesn't have physics because her parent doesn't have rigid body.
So we can browse through our assets folder.
We want the scene to fall down, so let's make sure to disable grabbing. And over here on constraints,
Wait. Oops.
our unit should really only move. There's our unit moving right and facing right. All right, awesome. Okay, so now we have achieved our movement by just moving the transform, but to make the game a little bit more fun, we want to use physics. We want our characters to be able to interact with other physics objects. So let's do example that. As usual, let's set up our unit over here with normal components. So let's select the parent game object. And this one over here, let's give the unit a shape. So let's give it a regular capsule collider. Then let's set up the settings. We can see over here on the scene view. So let's make it a little bit higher. So with a height of 2, for the radius 0.5, yep, that looks good. And let's just lift it up a little bit so it doesn't touch the floor. Let's say 1.1. Okay, yep, so there's our unit collider. And again, just like this, just by attaching a capsule collider, just this will automatically convert into .physics. We can already see down here, yep, the unity.physics.physics collider.
Oh, wait. We're not getting the physics. We have this attached to the pedestrian, but we're not getting the... We're not getting the physics yet. On this one, we're not even seeing the, let's go runtime. There's the move speed, yeah. But yeah, we're not seeing the physics.
This one will be added. So with this, we have a collider, and then for actually using physics, we also need a rigid body. So let's add that one, a rigid body. And again, just by adding a bunch of big components down here. Then for the rigid body settings, over here for interpolate, we want it to be nice and smooth, so let's make it interpolate. Then we don't want the scene to fall down, so let's make sure to disable gravity. And over here on constraints, our unit should really only move on the x.
Maybe? It's not giving it to me. What if I bring her back in? Okay, what if I give this the capsule? What if I give this a rigid body? So not even this has it. Huh. Okay, so that still don't have it. This is weird. Yeah, as soon as he added,
Either just this will automatically convert into dots physics. We can already see down here, yep, the unity.physics.physics collider, this one will be the parent game object. And this one over here, let's give the unity shape. So let's give it a regular capstone collider. Then let's set the settings. We can see over here on the scene view. So let's make it a little bit higher. So with a height of 2. For the radius 0.5, yep, that looks good. And let's just lift it up a little bit so it doesn't touch more. Let's say 1.
yeah, it immediately gave it to it. But even my my box here doesn't have it. I wonder if it's this. It's this. I don't have this. Rip. I'm going to laugh. Well, we're gonna find out. We're gonna find out 100% whether or not that was the issue. And it's gonna take a couple seconds to find out if that was the issue. The burst compiler is running. Look at that. It's almost like we have physics now. Holy shit. Does this have physics? Oh my god, it has physics. It doesn't have as many physics. This has physics velocity. Oh, right, because it has the rigid body, and this doesn't. I'm good. Do you want link? You're welcome to link, dude. If you have a link to something that's good, go for it. I'm learning dots here, so we can learn dots together, and you can be the expert. Is this new that you have to do this in Unity 6? Feels like it. Yeah, you have to install it. It's a Git. That's okay. They're using GitHub. It is just Git if it is not GitHub. GitHub does not have example.com. Bad documentation is bad. Where am I here? All right, I'm going to write down this. We are at 1 hour, 55 minutes, and 9 seconds in there we go. I think I'm gonna call it a night though. We are about a half hour off of an 8-hour shift, but I will be back again tomorrow for another 8 hours. And then I'll be back again the next day for another 8 hours, but I need to take a break. Let's see if there's anybody to raid here. Do What's up, Fox? I'm late. Yeah, you're late. I'm sorry. We can raid one of my art friends who's doing art. Oh, actually, wait. I've got a friend that's doing software. And I think they're in Blender right now. We'll go give them a raid. We made much progress on the dot. We made much progress on the game. We got dots started. We have a NPC moving with dots. Let's see if she moves. What's going on now? Is it frozen? Something's not working. We'll figure it out tomorrow. Anyways, please be nice to them. It's been a while since I chatted with them. Anyways, ta-ta for now. Thank you to everybody who showed up. I'll see you tomorrow morning.